Good morning, ladies and gentlemen, to the second day of our e-mobil BW stream, our program New Mobility Made in Baden-Württemberg, our contribution to the digital version of the Hannover Messe 2021. Of course, would have loved to be with our Baden-Württemberg pavilion in Hannover, but it is as it is. So we decided to organize a small little conference program yesterday and today and tomorrow. We have another session coming up. So the idea was just to give you a good impression and an overview over the different activities that are going on in Baden-Württemberg concerning new mobility, the future mobility, as you want to call it. My name is Wolfgang Fischer. I'm divisional head of project and cluster activities at e-mobil BW. That's the short version for State Agency for New Mobility Solutions and Automotive Baden-Württemberg. We are an innovation agency owned by the state of Baden-Württemberg, and we try to bring forward all the different topics of new mobility, electric mobility, fuel cell technology, automated and connected driving, not only alone, but in cooperation with a strong network of partners from research and a lot of different small, medium-sized and large companies of different branches, of course, from the automotive sector, but from the energy and the ICT sector as well. And of course, we have a lot of machinery companies in Baden-Württemberg as well. Just a short overview about what we did yesterday. We, if you hadn't had a chance to follow the sessions yesterday, in the morning we had the session about the software-defined vehicle. So we discussed different topics. We heard a presentation about universal software architecture as really a big issue for the upcoming generations of all different kinds of vehicles. And we discussed intensively what this means for the different companies from really technical aspects and of course other aspects concerning the organization itself and the way you can cooperate, you can work within an organization, with other organizations. We discussed a lot about failure culture and the necessity just to try things out, of course, with all matters of security and safety. Was a very interesting discussion. I learned quite a lot. One aspect, of course, concerning software-defined vehicle was the use of artificial intelligence in the mobility sector. This may be an aspect to discuss in the session we have this morning. In the afternoon, we took a look at, the title of the session was New Added Value through New Components. So we heard some presentations about producing electric motors under the conditions of the region of Baden-Württemberg. So we heard a presentation from the company Schaeffler, which is with one of their plants located near Karlsruhe in Bühl. Of course, a key component for everything concerning future mobility are batteries, energy storage solutions. Here we had a presentation from ADS Tech. It's a family-owned company whose headquarters is located in Nürtingen near Stuttgart. Actually, really a momentum at the moment is in the field of fuel cell technology. So we had a presentation about the HiFab Baden-Württemberg. It's a research factory for fuel cell stack production here in the region. And hopefully there will be a lot of cooperation between these research institutes and different industry actors here in Baden-Württemberg. And if we want to produce these new components here in Baden-Württemberg, one really strong condition is that the production has to be very agile, very flexible, modular. We had a very interesting presentation from the KIT yesterday concerning this topic. So if you hadn't had the chance to follow the different presentations, discussions of yesterday, of course, you have the possibility to see them afterwards in the following days on our YouTube channel, e-mobil BW. You find the link here. And if you already connected, if you see us, then you have already registered to our event platform, MEA platform. There are different opportunities for you viewers to participate. Of course, you can use the chat function of the platform to give us questions, as we did yesterday. So for today, if you have any questions concerning the presentations, if there's time left, we can just talk about them with the presenters directly after the presentation, but most of the questions we just take in our panel discussion afterwards with all the 4 presenters of today's session. And a second, I invite you to a second opportunity to participate. It's our wall of ideas. If you happen to visit our booth, the Baden-Württemberg pavilion in I think 2 years ago, we had on this booth a very large wall which was empty at the on Monday, as some sort of collaborative artwork and brainstorming. So everybody visiting our booth was invited to write something down there, to do some drawings and everything. And this, of course, you can do on our event platform too. So I invite you just to give us your ideas about future mobility and maybe the contribution that Baden-Württemberg can bring to this future or new mobility. So this about yesterday and the different ways to participate. Maybe some words to our session we have this morning. This morning we will focus on automatic and on connected driving. We have 4 very interesting presentations coming up, and we will have the chance to discuss certain aspects just later on in the panel discussion. Of course, autonomous driving is very much in the field of the research yet. So if you look at the presenters, of course, they are all coming from the really excellent research institutes and universities we have here in Baden-Württemberg. But one question I think we will see in the presentations and we can discuss in the panel discussion later on is when autonomous driving will come really in reality in the streets, and when it will be a topic. Of course, it's a topic for all our companies in Baden-Württemberg just from today, but yeah, it's a longer way, so we can really discuss a lot of different aspects. It's not only about technology; it's a lot about yeah, the law framework. There are some ethical aspects, and of course, it's a really interesting question how we organize the transportation and the traffic in future. And it's very important really to test all these things, not only in the laboratory, but really in the real life, in the real life situation. And this brings me to our first presenter of this morning, Dr. Alexander Viel from the Research Center for Information Technology from Karlsruhe, short the FZI. Alexander, it's really nice to see you in person this morning. We saw a lot in the digital space during the last month or during the last year, so I'm really happy to have you here. Before you start your presentation, some short words. You have a master's degree and a doctorate in computer science from the Karlsruhe Institute of Technology, short KIT, in the University of Tübingen. It's my alma mater too, so perfect. And yeah, you've been working at the FZI since 2004, and you are head of the division Intelligent Systems and Production Engineering. And yeah, just for your introduction, so I'm happy that you are here, and I'm looking forward to your presentation and to discuss some other aspects later on in the discussion. The stage is yours, Alexander. Thank you.
Thanks, Wolfgang, especially for the kind introduction. I'm also happy to be here and have a kind of a physical meeting under special circumstances. Yes, so when I was asked to give yes, an overview about our test area for autonomous driving, we built up here in Baden-Württemberg. Of course, I agreed, but however, I think for the Hannover Trade Fair, it's important to also show, yes, how it can be used. So not just the technologies in the test area, but also how it can be used for innovation and transfer, which means how to bring fresh ideas, how to bring technologies to the market, how to foster industrialization. So when you start discussing about kind of a test area, the people say, oh, well, what do you tell me? It's just for testing automotives, I guess. So, but basically for understanding what the real purpose is that you need to understand what are the challenges and demands for autonomous driving. Of course, this is a very, let's say, technology-driven area, so you need to consider technology, but also aspects of validation. So do the technologies really fit to the field? Do they really fit to the requirements in the field? Yes, but as you know, it's not just the driving itself, especially if you remove the driver, there may arise new mobility concepts and business models, but at the other hand, you also need to involve the user. So the social acceptance is necessary to be considered, and this is a very important aspect for such a test area. And as well, as we also heard in the introduction from Wolfgang, legal aspects play a significant role. And all those aspects together need to be considered for autonomous driving as well if you create an appropriate test area for such things. And usually you have some yes, iterative improvement in all the areas and not just one area that is solved and then the others will follow. So this means we need such a test area for more than just testing. It's also an enabler for different use cases that can be built up onto the test area. This means what we are doing there is an application of digital infrastructure, meaning it's smart and intelligent for the automatic public transport or of goods and people. This means that the infrastructure can be used for the testing, but also to be part of the system, especially if you use some sophisticated technologies where, for example, you would remove the intelligence from the vehicle and bring intelligence to the infrastructure. And in addition, you produce in such a test area lots of data you can use, for example, as live reference data from the infrastructure for the testing, but also to use the information, for example, into your vehicle to fuse together the impression that the vehicle has and what is provided by the infrastructure. If, for example, you're missing to detect an object outside of the vehicle. And this means we need a very sophisticated and complex setup of sensors that provide data, but also of the communication that brings the information from, for example, this infrastructure to the vehicles or among the infrastructure. This means we have, for example, multiple cameras that are equipped inside the test areas that can acquire the microscopic traffic, but also to have some roadside units that help in the communication between the infrastructure and then the vehicles. And then the question is, what do you do with all the data? Maybe you need a big database in the background to store some data, but you also need then some processing power that is connected, for example, to a backend in order to detect or to fuse some higher level information together. And basically, as this is a huge infrastructure, you also need some properties such as condition monitoring of the entire test area to know what works, or maybe if there's somewhere a problem you need to fix, or if this is a new aspect that poses new research questions. So one use case, I talked about use cases, is there, for example, the infrastructure supported driving. This means, on the one hand, on a very local basis, we have a smart roadside infrastructure that provides efficiency and safety of the autonomous mobility by supporting infrastructure. On the one hand, this means, for example, that the infrastructure supports or provides some reliable perception of the traffic participants and also provides real-time communication and advice if a system is not really sure what to do or which alternatives exist. This means at that aspect, the smart roadside infrastructure enables safety and some core functionality for the technical systems. On the other side, you also have some aspects of global connectivity and interoperability. This means, based on such a digital infrastructure, you can create globally optimized services, for example, to improve public transport and also to bridge transport of people and with logistics of wares and goods. And if you would then put this into the global context and allow connectivity among different services and systems, you can have additional synergy effects that would lead at the end to a more efficient and green usage of resources. So this means, using such global visions, a test area can foster a technology spread and serve as an innovation platforms, not just on the very local side. So let's have a look what does digital infrastructure look like and what are the building blocks, the basic building blocks we foresee there. So this is a sketch of a city you see here, and there are different aspects and different building blocks you see. For example, we have intelligent traffic lights that communicate with the vehicles. We have some additional mobile sensing. This could be the traffic sensors, this could be weather sensors or some other conditions. Then we have the communication aspects I already referred to, meaning, for example, using LTE vehicular, 5G or Wi-Fi connections that are available there. Then one very, very crucial aspect is the intelligent environment and sensors that provide additional data to support, for example, the driving or the testing. Then we need some background information, for example, high definition or high precise maps that can be used to support the driving or, for example, to test some detection algorithms. Then we have the roadside units and some additional intelligent transportation systems communications and some back-end that on the one hand provides services that on the other hand can serve as kind of a digital twin in order to find some problems that might arise, but those during the simulation, this means they're also reproducible. And something to really say, you cannot just create a test area inside a living city, maybe outside in a city in an industrial area, but you need lots of support. You need a network, for example, the governments, the legal bodies, certification units, but also then industrial partners that provide technologies you need. So far from the general concepts, now I would like to show a little bit about the physical deployment. So how does the test area look like so far? And yes, as it's called Test Area for Autonomous Driving Baden-Württemberg, it's not just deployed in Karlsruhe, but I would like to take a very interesting area in Karlsruhe in order to show you what has been done. So on the left side, you see a map that shows the eastern part of Karlsruhe, or just a part of the eastern part of Karlsruhe, between the highway A5 and, let's say, the center of the city. And there's the road network. And what you see here maybe is the pink tracks are the tracks in that area where we have this high precision 3D maps. And then there are two different kinds of circles, the red circles and the gray circles. And the red circles have a full sensor setup. This usually means they have cameras, they may have LiDAR sensors, or they may have, for example, also radar sensors in order to do some additional, let's say, for example, perception analysis steps. And then there are the gray intersections that have support of car-to infrastructure communication. Means at this point, for example, the information of traffic lights are communicated to the vehicles. Yes, but how does it look like? I depicted here two examples from different intersections. So the upper picture is yes, an aerial image of an intersection, and right next to it you see what it means. So the intersection existed, and it's an intersection that also integrates public transport, rail-based public transport, and there we had to equip a lot of sensors, but also to create the connectivity inside this intersection for being able, for example, to stream the data, to analyze, to have a computational pipeline that identifies objects, characterizes them, and stores necessary or interesting information, such, for example, yes, movement directories or movement patterns. On the lower part you see a different intersection, and there you see, for example, some information that are stored in the back end of the test area. So, for example, what we are not doing, also especially due to the GDPR, is to store raw data, but what we are doing is, for example, to detect and classify objects. And what you do then see in this moving area, that there are some objects with a certain speed and a trajectory that are somewhere in time. And on the lower image you see, for example, the different lanes that are in the intersection and the status of the traffic lights that say, okay, this is green, red or yellow so far. So just for giving you a glimpse what we are doing in the test area with the different technologies. And for coming to innovation and transfer, I think you have now seen that it's not just testing vehicles, it's also to support the creation of new services, and one strong instrument for really bringing companies to that area. This means some companies already have, let's say, their development stack, their development plans for going towards, let's say, autonomous driving. But there are also other companies that would like to get in touch with this topic area, or to develop services that are not fully related or necessarily related to autonomous driving. And I think that public-funded research projects are very good to bring innovation and transfer, also using such a test area. And I listed here some examples of projects that are currently running on this test area. For example, the project EVA Shuttle, which means electrified, connected and autonomous shuttle buses for the last mile, which are deployed in southern Karlsruhe in an area where they serve since yesterday the public transport. So this means they're transporting people powered by an app. And here one of the challenges was that you're not serving some predefined routes, so that it's on demand. You can call via an app on demand using the test area infrastructure, such an automated shuttle bus, and say where you would like to be brought. Then there's a very huge activity called SHOW, financed by the European Union. And there's the test area is part of the mega site Germany there in Karlsruhe. And what we are doing is to demonstrate different autonomous driving technologies, especially with emphasis on public transport. And there we also explore not just transport of persons, but also of goods as a first initiative. And then there are, I would call it different activities, for example, funding program by the state of Baden-Württemberg called Smart Mobility with several projects. Then there's the high performance research area called Profilregion Mobility Systems, which, for example, establishes a virtual test bed of the test area Baden-Württemberg for the verification of driving functions. And then there's, for example, this Lighthouse project family from the German automotive industry, association VDA called Connected and Autonomous Driving, and there's a lot of projects, and at all we just summed up how many projects are actively working currently on the test area, and it's at least 20 projects I counted yesterday, and the number is growing. I think we have lots of interesting new projects in the pipeline, and when counting the institutions that are part of the projects. And institutions does not just mean research institutions, it's also large industrial companies, it's SMEs. We count more than 130 institutions that have directly or indirectly within projects access to the test area, and then, develop things, try new things out, and test vehicles. So, for concluding, what I said is, from our point of view, the test area for autonomous driving Baden-Württemberg is an open innovation platform for research and transfer projects, and hence contributes to the industrialization of lots of those autonomous driving technologies. Thank you.
Yeah, thank you very much, Dr. Alexander Viel, for the insights in the testing area for autonomous driving. I always call it tough BV in my mind, so that's the short expression around it. As we have 20 seconds left, maybe a short answer. Just if we talk about small and medium-sized companies, from your perspective as a researcher, what is your advice for them? Is it really going into joint projects with the research institutes?
So anyway, I would always say be fast. Whatever you want to do, be fast. Because if you're fast and have a good idea, there's a market. And I think that research projects are a very good vehicle, but you need to take care that maybe even if it's a 3-year project, that after certain, let's say, milestone, internal milestone, you already have something that is kind of results that you can then bring to the market, bring to products. But I think in this, let's say, in this area where you have then the collaboration with the big industries that might be your first customers, and then also with the, let's say, research institutes, with the universities that have the latest technologies. It's a very good aspect. And then if you have a test area, it's a very good setting for starting to make some successful business.
Thank you. We can go more in detail in the panel discussion. So thank you very much for now.
You're welcome.
So we are going to our second contribution of this morning's session. I'm very happy about our next presenter to introduce Professor Dr. Tjaak Siefkes. He is director of the Institute for Vehicle Concepts at the German Aerospace Center, short DLR, here in Stuttgart. He in his life from 2000 to 2012, he was Vice President Research, Product Management and Competence Center at Bombardier Transportation. Then a few years head of system engineering and light sources SAML, and from 2019 he joined the German Aerospace Center, and you will present us a project or a project universe called U-Shift, meeting the requirements of future urban road traffic. We are happy to have you here. Professor Siefkes, the floor is yours.
Thank you, Wolfgang. A warm welcome from my side to the audience on the screens. U-Shift, meeting the requirements of future urban road traffic. The title, as it says, we first have to dig into the requirements. Where do they come from? They come from, of course, protecting our climate. Green Deal, for example, is a buzzword, a catchword nowadays here. But on the other hand, it's also about ensuring mobility for the future. And both don't necessarily go hand in hand, even they are contradictory at first. So what we have to do is, what we are aiming for is to manage the transformation of transport and ensure that these gears really go twos and twos. How do we do this in the German Aerospace Center? We are roughly 10,000 employees, not only, as the title says, working on space and aeronautics, but we're also focusing on ground traffic, on energy, on digitalization, and as well as security. So we can dig into employees which are working in technical areas, but also employees which are focusing on other domains like psychology, medicine, etc. This enables us to think in systems. I only are going to look into two questions here. On the transport system side, for example, who will be driving in the future? That's what we are going to address today. But on the psychology side, of course, also is a big question. Do I need to know what the vehicle knows? And there's a big branch of questions which needs to be taken into account when we want to do the transfer of transportation into the future in a good way. Looking at the Green Deal, the European Green Deal, I brought this graph for you. On the y-axis, we are looking at decarbonization of transport. The Green Deal says, please do decarbonization by 90% compared to the reference of 1995 for the whole transport area, which means that, first of all, we have to make the primary energy completely out of wind, sun and water energy, but also the industry production needs to be environmental friendly as well as the direct emissions. And as you can see, it's a tough target because when we move from summer to winter in Central Europe, then we need to store a big volume of energy to have regenerative energy also available in winter time when it's dark, also at night time when there's low wind times. So it's a big risk to achieve that goal, and there's a big variety and a big chance that we're going to miss this goal. So forget about this y-axis. I brought you another solution. This is put on the x-axis. What if we only are going to use 10% of the energy we used for transport in 1995, then in 2050? So energy reduction by 90%, and bingo, we are there where we wanted to be. And of course, obviously, that's also not going to work out for technical reasons. So the only chance is to combine both, and this is the solid line, the solid yellow line you can see in here, which gives us a target corridor for 2050. So the energy reduction on the technical side, feasible is roundabout between 40–45% at maximum. This is what we can achieve. But if the decarbonization rate really goes below the 90% target, then this target corridor becomes easily very small. Same goes for the EU plan for 2030 for the fleet emissions of the manufacturers to be targeted at around about 37%. Also here the target corridor is pretty small. So we have to combine both activities, political activity in decarbonization and technical activities in energy reduction on large scale. There must be a handshake between politicians and industries, and this is the only way out of this dilemma we see here. But there's more to it than just decarbonization. We're looking at health, for example, in urban areas. We have the cap issue that providing courier, express and parcel services, which are heavily grown currently, are disturbing inner cities, producing emissions, more and more emissions. So the expected cap rate in Germany in 2022, now with the focus on the pandemic problems, probably are going to be even higher than the originally predicted plus 33%. So what we see is that large amounts of courier and parcel services being operated in inner cities. If you look into other countries like China, for example, we have even higher rates here, around about between 45 and 60% growth rates. That is what we see. So the majors of the cities, like Stuttgart here, they are going to try to eliminate private traffic in urban areas, which creates a problem situation which is multi-layered and highly complex as well. We're not only looking at mobility infarction and the health endeavors, which we just discussed here. We're also looking into technical questions where we see increased competitiveness pressures from Asia put on our automotive industry. So there's high innovation pressure we see here. And of course, fears in society and in politics about what is really going to happen in the future with a high amount of activity on all levels and still quite some low coordination. This is, as I originally said, needs to be changed. We have to go hand in hand in our approach. There are multiple approaches here. What we can do is, of course, entangle freight and passenger transport. If we make freight transport environmental friendly, low noise, etc., electric mobility, then we can put this into the night times and do the passenger transport at daytime. And of course, to face the pressure from Asia, for example, we have to be more efficient here, like a 24/7 operation of the capital-intensive systems we have here, and that is traffic, of course, as well. So the use of digitization is one part, but also we have to create new business models, looking at citizen participation as well to address fears in society. And overall, it's an integrated approach, which leads to a really leapfrog innovation and not just step-by-step enhancements. This is how we created USHIF. And we, that is the University of Ulm, together with FKFS, Technical University of Karlsruhe is involved as well, where we look at various areas. So we look at on-demand transport, automotive or mobility as a service as well, but also at the small and medium-sized enterprises. How can we ensure that they develop for the future to come? And this is where we help them as well. The whole thing, UShift, is invented in Baden-Württemberg. We are proud of this, and the SDA, which is our host here, is highly supporting us and driving us into this future. How does it look like now, this UShift, let's call it truck, maybe it's the best word. It's a highly modular vehicle, which is modular on the road. So it changes during service between parcel transport, for example, passenger transport, so cargo and passenger transport. And everything what is costly, we put into this drive board, the white vehicle, for 24/7 hours operation and for autonomous transport as well. The cargo capsules, that is where the medium-sized enterprises, companies can dig their teeth into. They're intermodal in size, in shape, they're highly standardized, but also employ individual functionalities as well. Same goes for passenger capsules, for on-demand transport, for edge zone operation, as well in time as in place in urban areas. So in overall, what we can see here for UShift, it really integrates today's vehicle concepts, bringing them into the future with integrating plant engineering concepts, that is just, for example, 24/7 operation, and making that leapfrog innovation possible. It is highly modular, not only in operation on the road, but also in its layout. We have foreseen currently 3 sizes, large, medium, and small. The medium size, what is named in German Kleinbus, that is a 3.5 ton U-shift, which operates 10 to 12 people on the one hand, or has a payload a little bit larger than 1 ton for cargo transport. So U-shift is scalable in size as well as in business services. This is one thing. The other thing is that it is not easy to operate autonomous vehicles in urban cities. This is what we are addressing in the whole conference today here. With U-shift, there is multiple challenge which comes upon us. It needs to be safe and secure, of course, operating in inner cities. But what we also need, we do on-demand transport, when we do on-demand cargo transport as well. We need to have a traffic control center. Fleet management goes with it. And of course, to minimize energy usage, to achieve a Green Deal, we have to have a strategic routing and deployment planning. So it cries for a kind of transport center in the back end, which has to run edge computing, of course. We need to see how much energy we put on the U-shift, as well as how much energy do we put into infrastructure. We need to foresee a good mix here, also to minimize the computing energy in overall. The road capturing units, of course, have to go hand in hand with the deployment questions. Probably we are going to see sensors at big crossings, at highly secure areas in the inner cities. So sensor units also have to go hand in hand, of course, with the general data protection regulation. That is where I say it's more than just technology, it's psychology, it's also about then legal questions we are addressing here, giving us the big flower of U-shift to come in the future. So it's all about managed automated driving, which we are tackling in the years to come. What did we do? We built a first prototype of this U-shift vehicle. Here you can see the white drive board, we call it. That is where we have the autonomous part in it. The batteries are placed in here, the electric motors gearbox, and it is tailored to pick up different settings like what you can see on the right side. The passenger module, the passenger capsule. Also on the left side, on the next picture, you see then the cargo capsule. In this case, we produced example-wise cargo capsule, which is refrigerated, which then also extends the discussion about energy distribution, connectivity on the whole setting of the car, of the autonomous car, and the capsules we put on them. So overall, it's quite some time to go to make this really finally operation at SAA level 5. We have demonstrated it on Stuttgart Fairgrounds. It's an enclosed environment where we can do the operation. But until certification and operation in mixed traffic on the roads, it's some time to come. I'm happy. I'm looking forward to this. I'm happy to run this project as well, together with the mentioned colleagues from the other research institutions. And with this, I would like to say thank you again for listening, for being here with us on the SDA Digital Hannover Fair. Thank you.
Thank you very much to Professor Dr. Tjag Siefkes from the German Aerospace Center. I have a really interesting question, but I would suggest looking to the time that we come up to this in the panel discussion. But yeah, just a very short question. I mean, U-shift is a very modular and flexible concept, as you pointed out, and you also pointed out that operating autonomous vehicle is not that easy. It's quite difficult. So actually, the possibilities are really broad. So what do you think in future? Will it will we have a mixture between the operators transporting persons and goods, or will it be different? Will there come a completely new operator, or will it be the operators we know from today but with new knowledges?
It will be a mixture. So it's not a black and white here. What you're going to see is that there are operators like we have them today running public transport. They will use this, they will put it into a mixed operation. There had been some examples for trams, where trams in nighttime deliver cargo. In Frankfurt, for example, in Berlin, we saw this. So you can do this on the road as well. But others, as current logistic companies, cargo device companies, they're going to use one part of U-Shift and then hand over the drive board to other companies who only do passenger transport. So you see then there will be a kind of a leasing, a new type of leasing for the costly drive board, and then the cheap and simple settings for the cargo capsules, for the passenger capsules, that will be then owned and managed by different companies as well.
I think we can go a little bit more in detail in the panel discussion afterwards. So thank you very much for now, for your interesting presentation. And I'm looking forward to discuss with you some more aspects in a few minutes. So we're coming to our next presentation. We already heard about the testing field for autonomous driving in Karlsruhe. But the city of Ulm is a very interesting test site for automated vehicle, as well as one of our hotspots for this topic in Baden-Württemberg. So we are very glad to give a warm welcome to Dr. Michael Buchholz from the University of Ulm. You're working for the Institute of Measurement Control and Microtechnology. Since 2009, I think, so more than a decade already before you received your diploma and your doctoral degree from the Faculty of Electrical Engineering and Information Technology at the Karlsruhe University. So the same as I said to Alexander, we met a lot digitally in the last year, so it's really good to see you here, and I'm looking forward to your presentation and discuss with you later on in the panel discussion. Michael, the floor is yours. Thank you.
Thanks, Wolfgang, for the warm welcome, and welcome to all of you to my presentation on supporting on how an intelligent infrastructure can support connected automated vehicles. What I'm presenting here is more or less the result and ongoing work which we do in several research projects. But to give you a little spot on the background, the Institute of Measurement Control and Microtechnology, our director is Professor Klaus Dietmeier, and he founded the group of automated driving, driver assistance systems about 20 years ago. At the moment, more than 20 researchers are working only in the field of automated and connected driving, and additionally many students. We are a partner in several public funded projects, for example, the U-Shift project, which Tjalk presented just in the presentation before, on a state of Baden-Württemberg level, but also in federal funded projects like the Unicar Agile, the Lucas project, or on a European level, the ICT for Cloud project. In addition, we have several research contracts with OEMs and suppliers. On a methodology side, we focus on information fusion, multi-object tracking and localization, and also machine learning for classification and scene understanding, just to mention 3 spots where we really focus our work. Overall, we work on the whole chain of automated and connected driving at our institute. But now coming to the main topic of the talk, the connected automated vehicles and the infrastructure supporting them. I personally led the work package in the ICT for Cloud project, where you can see the partners on the right side, and the work package on the high-level system architecture. In this project, we developed an architecture which is able to integrate several different communication technologies. In In this project, we focused on the LTE 5G mobile communication, which you can see on the right side of the architecture picture, and the ITSG5 or dedicated short-range communication, DSRC, as you can see on the left side. And then we have sensors in the infrastructure, for example, which are either connected to the mobile network, like on the right side, or directly have an ITSG5 RSU, like shown on the left side. And to allow for very low latencies, because real-time applications for automated driving don't allow for a long transportation and delays in mobile communication or even wired communications, you have so-called mobile edge computing servers, either on the base station of the mobile network or directly at the roadside units of the ITSG5 network. And also the sensors can surely be connected to both, and we call that a hybrid communication. For sure, we also have some services which are not latency critical. So these can be in the cloud, like back-end services of OEMs, different service providers like map, weather, or whatever. And this can be provided over the internet to those vehicles. And you see the vehicles, which are kind of like agents or clients in that system from an infrastructure point of view or communication point of view, which can either connect via ITSG5 or via 5G or LTE or both, so they can use the hybrid communication. But now coming more in detail to the vehicle. So what are the functional modules of a connected automated vehicle? For sure, an automated vehicle needs sensors to perceive the objects and its surroundings. We need a very precise HD map and a differential GPS transceiver to know where we are. Using the map and the GPS and also sensor data, we can have a very precise localization with respect to that map. And the sensors detect all the moving objects around us, so the other vehicles, the pedestrians, the bicyclists, and all that. And this is all together summed up in the so-called environment model. Based on that model, the vehicle has to understand what's going on around it and then has to decide what to do to reach its goal where it wants to drive. So it has to plan its behavior and then plan a trajectory. That's the direct way it's going to drive in the next few seconds. And then the vehicle has to be controlled to follow that trajectory. So now how can intelligent infrastructure support that vehicle? You can have infrastructure sensors, for example, as a first step, which also provide an environment model from their view on the scene, for example, at a crossing, a junction. And then this environment model can be sent to the vehicle, but then in the vehicle, you have to be sure that this data is valid, that it's reliable. So what you normally would have is some kind of reliability check, which needs to check the reliability on very few samples. So normal statistics on large numbers don't work here. I want to give you a short, more detailed example on exactly that application, which was part of the MacView project, which we finished last summer. We call that the virtual mirror. It was performed on our test site in Ulm, where we have intelligent infrastructure sensors on public roads and in the suburban area of the city of Ulm at a T-junction, which has no traffic lights. The driving task for the autonomous vehicle, which you see in red, is to drive onto the junction and merge either right or left on this T-junction and yielding the right-of-way of the priority road. But as you can already see on the right side, buildings or other infrastructure elements could occlude the view on the main road for the automated vehicles. So from its own onboard sensors field of view, it cannot know if there's a vehicle behind that building or not. So the red area is not visible for the vehicle at the moment. So what it normally would have to do at this junction would be to drive at the yield line, stop, sense the environment, and then start again, which is not very efficient for the other traffic, for example, and also for the energy consumption. To give you a more detailed view on how this looks at the intersection, I have a video from one of our test vehicles. When we start this video, you see from a cam what the sensors of the vehicle would also see. So you see the building on the left side, and we are not almost there at the junction, but we can see through the building. And what we want to have is that infrastructure sensors open that field like if the building would not be there. So that would be our goal that we want to achieve with our infrastructure sensors. So the solution is to use infrastructure sensors and to extend with them the field of view of the automated vehicles which are connected to those sensors. Then an environment model in the infrastructure can extend the field of view and makes the occluded road users visible to the connected automated vehicle. And then the vehicle can already make its decision long before it can sense the objects itself. So what was the infrastructure setup for this field test which we performed last year in Ulm? We have sensors with sensor processing units. In detail, we use cameras and LiDAR sensors at lamp poles, and the sensor processing unit already did a pre-processing. So they detected the objects from the sensor data and only sent the object data via mobile network to a MAX server. The LTE 5G mobile network was a test network by our partner Nokia, which performed with very low latencies and features a mobile edge computing server. And all the SPUs and also the vehicles connect to that server and can receive the environment model, which is calculated on that MAX server. This model fuses and tracks all the objects from the received from the sensor processing units, but also makes a prediction of how the scene will probably evolve in the next few seconds. This makes sense because a vehicle only can make a prediction which is very general, because it has to work on any junction in the world. But for the infrastructure, this is can be a very tailored prediction which perfectly fits the behavior of the other vehicles at this intersection. And the prediction allows, for example, to account for latencies which occur, or also to predict how the movement will be, so that we can have a predictive planning of our own behavior. Now you will see a video. On the left side, you see the front cam of the connected automated vehicle. And on the right side, you see in green the road boundaries. In blue, the boxes are the objects from the environment model from the infrastructure. And the red dots are the LiDAR sensor points from the vehicle. And I will start the video, and you will now see that the vehicle, with that information from the MAX server, with this environment, it can directly merge behind the vehicle onto the main road and not anyhow braking. So this is very energy efficient and also efficient for the traffic flow at this intersection. But is that already anything what we can do with this infrastructure? Is this the only intelligence to perceive objects from installed sensors? No. In ongoing works, we work on also integrate road users' data, the objects their own positions, and also the objects they may retrieve. We also integrate vulnerable road users like pedestrians or bicyclists using smartphone which are connected to the MAX server. And then the server can also work on cooperative maneuver planning. So it can provide some suggestions to the vehicle how to behave at this intersection, which then also has to be checked for reliability, and then can be driven by the automated vehicle connected. Is it already all, or is there something which is beyond that? You see a wide, free area in the right, and for sure the next step could also be that we have also trajectory planning in the infrastructure, and the vehicle only checks if this trajectory is available. This is more or less the managed automated driving Tjalk was talking about in the talk before, and this completely adds up to this idea. With that, I want to thank you for your attention. If you have any more questions, please feel free to contact me, and I would also like to thank our funding agencies, the Federal Ministry of Economic Affairs and also the European Commission, which funded those works in the projects MacView, Lucas and ICT for CART. Thank you.
Thank you very much, Dr. Michael Buchholz from the University of Ulm. As we have 2 minutes left, I have 1 or 2 questions to discuss with you. So you presented a lot of interesting aspects concerning infrastructure. If we just think of the future transportation system, so I would assume that brings some. If we look at the project partners in your project, so this brings some new kind of actors in the mobility sector, which were not in the mobility sector in the past.
Right, totally right. For example, I said our test network is operated by Nokia, so we have all the many partners which we have in those projects are from the communication area. So we have OEMs and suppliers like Bosch and Daimler or BMW in those projects. But on the other hand, we also have Nokia and the typical traffic infrastructure suppliers like Swarco, for example, which are partners in those projects. And they more and more work closely together now for getting that infrastructure for the intelligent driving running. And this is not only for the automated vehicle itself, but as you said, also for intelligent transportation systems. So having a more global look on the overall systems to get the, for example, for traffic efficiency also.
As we have very intense discussion about digital infrastructure in Germany, is 5G or in future 6G, is it really crucial to have intelligent transportation in the future?
It depends on which task you want to have. If you say the vehicle should always perform each situation on its own, then you wouldn't need that. But if you want to have services like I presented with the environment model, you would need at least a 5G with a low latency possibilities, which only 5G offers, so that you really have very low transport delays of the information between the sensors, the MAC server, and also the vehicles. Because otherwise, if you have to transport that via LTE to some cloud server, the information would be too old and the vehicle could not rely on that.
So still a lot of work to do.
Yeah.
Thank you for now, Michael. We will see each other again in the panel discussion.
Thank you.
So thank you very much for the interesting presentation. And we come now to the 4th contribution in this morning session. I can give a warm welcome to Dr. Ulrike Weinrich. From the Research Institute of Automotive Engineering and Vehicle Engines in Stuttgart, short version FKFS in English. And you will tell us about a project which started last year, the RABus project. The title of your presentation, Are We Ready Yet? I really like that as an open question. We really had the pleasure to be involved in the RABus project from the early beginnings, the first discussions with the Ministry of Transportation in Baden-Württemberg and all the project partners. So welcome. It's nice to have you here. And I'm looking forward to your presentation.
Thank you, Mr. Fischer. And I'm the project manager of the project RABus at the FKFS. And I'm going to show you how we intend to bring automated driving to the streets with our project. I was stuck in traffic. How many of you have said these words once or twice before? I mean, I live in Stuttgart and I said it quite a lot before the year 2020. The facts are that traffic jams cost the German economy 2.8 billion euros in the year 2019. In the same year, the average greenhouse gas emissions of a passenger car were 143 grams per passenger kilometers. One could, maybe solve this problem with emissions by replacing the internal combustion cars with electric ones. But we would still be stuck in traffic. In Stuttgart, the time lost in traffic jams was 42 hours in the year 2019. This is actually almost 2 days we spent in traffic jams. To solve this, one could maybe use some automated vehicles to do something productive while you're still stuck in traffic. But if we're really true to ourselves, the words "I was stuck in traffic" really sound like the traffic jam was inflicted on us. But if we're really honest, isn't it true that actually we are the traffic? So that is why we think it is really important to see that automated driving in public transport is an opportunity. Of course, here we have some boundary conditions like the legal situation, like saying the licensing of the shuttles, which could become a little bit easier now with the new laws that are actually in the making. We have liability issues, and we also have some issues considering the data protection. Of course, we also have to look into the reliability and safety of these autonomous shuttles. And for the public transport companies, it is also important to look into the efficiency of these kind of transports, because as a transport company you have to look into the total cost of ownership, which consists of the buying the shuttle, but also all the costs maintaining the shuttle throughout this lifespan. Next, we also have to look into the acceptance. So we have to learn and to see if passengers are really, or if people are willing to use this kind of shuttle and this new technology. And lastly, we also have to look into the transferability. So we can't only, we want to use these kind of shuttles in certain areas and cities and so on. So this is why we came up with the project RABus. RABus stands for the Real Laboratory for Automated Bus Operation in Urban and Rural Public Transportation. Here in RABus we have 2 real laboratories for the electric, automated and connected bus operation in public transport applications. This is a consortium consisting of 6 partners from research and science, public transport operators, but also the industry. The project is publicly funded by the Ministry of Transport, and here you can see Minister Hermann when he handed the approval for grant to Professor Reuss from the FKFS. Real laboratories, just to give you a quick insight, this is actually a nice setup, because here you can test new functions, new features, your autonomous system, and you have an enclosed environment, and for a limited set of time you also can get some exemptions from existing laws so that you can actually test your system and if it works under these new circumstances. One of our real laboratories is in Friedrichshafen, and here we're going to look into the urban and the rural application, which means we also look into the mixed traffic on the roads, which means the shuttle doesn't have its own lane, but it has to drive with all the other cars and bicycles and so on the open road. In Friedrichshafen, we look closely into a cross-section of traffic and requirements, which means we have 30 km/h zones, but we also have country roads with speed limits up to 60 or 70 km/h. The operation in Friedrichshafen of the shuttles will start in 2023. And on the other hand, we have Mannheim. In Mannheim, we develop a new residential area, which is called Franklin, and it used to be a military base, and now it is converted into this new residential area with up to 10,000 inhabitants. Here in Mannheim, we're going to look closer into the driverless operation, which means that the safety steward, who is in the shuttle, of course, in Friedrichshafen and in Mannheim at the beginning of the project, but in Mannheim, we're going to try to take him out of the shuttle and put the operator into a technical supervision, which is going to be set up in the control center of, in the end, the public transport companies. In the end of the project, we also want to look into a concessionary line operation, which means the passengers also have to pay for this kind of shuttle service, or we ask them what they're willing to pay for this kind of service. In Mannheim, we're going to start with the operation the next year in 2022. The shuttles are the Group Rapid Transit shuttles from the company To Get There, which is a 100% subsidiary of ZF. Here I'm going to just go quickly over some facts. The shuttle has a capacity for 22 passengers, which means we have 8 seats and space for 14 standing people. And the shuttle can charge from 30 to 80% in 10 minutes. Of course, because we are a research project, we also do some really nice scientific monitoring. On the one hand, we're going to look into the acceptance, which means we're going to do some questionnaires with all the passengers and users and non-users, and we're going to ask them what their reasons are to use the shuttle, or maybe why they're hesitant, and how we can overcome this fear against these kind of shuttles. On the other hand, we also do some traffic evaluations, which means we're going to take the data from the operation of the shuttle, feed them into some models from the operation, and then we're going to transfer these findings into other areas as well, so that we can actually see if the bus shuttle operation from Friedrichshafen and Mannheim also works for cities like Hannover or Stuttgart as well. At last, we're also going to do some technical monitoring, which means we're going to look into the localization of the shuttle. So we're going to see if how robust it is and how reliable. And also we're going to see or going to look into the obstacle detection, like other bicycles, other cars, or people on the street as well. This is why we think RABus has some really good, quite nice added values from different point of views of users and people involved in this kind of project. On the one hand, we have the population who gets a safe and comfortable shuttle service, and also can expect an expansion of the public transport services for the rural areas as well. For the politics, with a goal of the transport turnaround by 2030, RABus gives some really good experience regarding the operation of automated driving or autonomous shuttles in the public transport section. For the transport companies, we're going to closely look into the economic operation of these kind of shuttles, and we're going to see if there are even some more or some new possibilities to use these shuttles, like, for instance, the 24/7 service or the last mile connection as well. For the science, we're going to look, or we're going to see how the acceptance and the motives of people and the passengers is towards these kind of shuttles, and how we can help them overcome the fear and what they need, what kind of assistance they need. Moreover, from learning how the car turns around the corner, how it stops, these objectives really gives us, objective data gives us a kind of reasons why, or feeling for the passenger's sense of safety, and when he feels safe in the shuttle, and what kind of behavior doesn't feel safe anymore. For the industrial companies involved, we're going to improve the reliability and safety of these kind of shuttles and autonomous systems, and we're going to help safeguarding the functional safety of these systems as well. In the end, I'd like to show you how the project RABus fits nicely, or is a nice addition to the project portfolio at the University of Stuttgart and the FKFS, together with the project RABus, which is another publicly funded project by the Ministry of Transport, where the university is involved. We're going to set up these, or we have these real laboratories. On the other hand, we also see these vehicle concepts like the project Unica Agile, where the University of Stuttgart is involved, where a disruptive modular platform for hardware and software is developed. The project U-Shift, which Professor Siefkes already explained to us, where you can take the transport module, or you separate the transport module from the transport from the capsule, and the project FlexCar, which is a joint project at the Arena 2036. Where also another platform for the vehicle of the future is developed. On the other hand, we also have mobility concepts like the Mobility Living Lab, or so-called MobiLab, at the campus of University of Stuttgart, where, with the plan of the university to have an emission-free campus by 2035, the idea is to take all the cars or vehicles out of the campus, so the campus Flying is going to be car-free by that time, and in order to access the campus then, you're going to have to use public transport or local bike shares, or if you're really dependent on your vehicle, you have to park your car outside in the parking lot, and in order to access the campus, you have to use an autonomous shuttle as well. So, I'd like to thank you for your attention. I hope I'm going to see you in the next couple of years in one of our real laboratories in Friedrichshafen or Mannheim. And if you like, stay connected with us through our website as well. Thank you.
So, thank you very much, Dr. Ulrike Weinrich from the FKFS. Yeah, as we have 1 minute left, just one question. I'm not sure if you really have an answer to that right now, as RABus is in a really early stage. But yes. If you look at the public transport, yes. So this could be more really like an evolutionary way, just to have some new possibilities with the new vehicles, or will it really be a revolution of the public transport, as these shuttles are really a complete new mode in the whole yes. Intermodal system. What's your opinion about that?
We see RABus, or the findings of RABus, as an addition for the public transport. Mm-hmm. So we don't want to replace anything that's here yet, but we want to expand new denser lines, or even the more shuttle services, or for even other times which aren't really economic at the moment. So.
So it brings more possibilities for the users. That's, yes. I think that's a point in a real laboratory.
Yes, but even for the public transport as well, because at the moment, if we can't find any drivers or for certain routes, you have to cancel them. And now we're gonna give them the opportunity to expand the services again.
And especially in some late night, or especially time frames where it's not really attractive yes. to be a bus driver. So this could be a really good possibility. So thank you much for your interesting presentation. I'm really looking forward to the RABus project in the following years. Thank you for this time, and now we just go on to the panel discussion. To our viewers, we now have a really short break to prepare everything for the panel discussion. If we would be a television network, I would say a short commercial break, but it's not commercial, it's just a break, a short break, and we come back to you in a few minutes with our panel discussion. Thank you.
Baden-Württemberg?
No. Baden-Württemberg.
Baden... what?
Baden-Württemberg. Baden-Württemberg.
So we are back as announced after a short, it was a little bit commercial break. It was a movie about Baden-Württemberg from our agency Baden-Württemberg International and all the other agencies as we are one. So let's start in the discussion. I welcome on this panel discussion the presenters of this morning session. Starting at my left, Dr. Alexander Viel, Professor Dr. Tjag Sivkes, Dr. Michael Buchholz, and Dr. Ulrike Weinrich. So thank you for your input presentations. Now we have the possibility to go on a little more, on a few questions more in detail. I would like to start with a short starting round. Let us just imagine a highly automated, connected and sustainable mobility system, which we all want to have in future. What are, from your opinion, from your projects, your activities that you presented, what are the main challenges that we will face in the coming decade, especially in order to bring really autonomous vehicles into the field, onto the road? So maybe we start.
Me first? Personally, I think the main limitations at the beginning were the laws which we were facing and the boundary conditions, considering how you get this shuttle on the road and what you have to do for it. And these are actually, for us, are going to be less limiting once we have the new legislation. And I think this was like the main, I think not fear, but what we were afraid of, what will come the next couple of years. But we're really happy about what's going to happen now and how this is going to help us and other projects as well to bring new types of systems onto the road.
Michael Buchholz?
Maybe I can add that I think one of the main challenges is the transition we will have. At the moment, we have manually driven vehicles on the road, which are mostly not connected, or many of them are not connected. For sure, we have pedestrians, bicyclists, and so on. And if you would switch to a completely connected environment immediately, many tasks of the automation would be much easier. But we have to, make the automation work in an environment which was made for the human driver. And I think that's one of the main challenges we have. And there has to be a transition which is, on the one side, still allows the infrastructure owners, like the cities or the countries, still to pay for the additional digital infrastructure. That shouldn't be too expensive, otherwise it's not feasible. But on the other hand, the vehicles have to handle that there are many vehicles on the road which are not automated or which don't get that information. I think that this is one of the main challenges we will have in the transition phase.
Mm-hmm. Yes, I agree with Michael. Mixed operation is the biggest challenge we see. And it's going to be mixed operation probably for the next 20, 30 years to come. So that is one big challenge. The other big challenge is, of course, to make it safe and secure. Just giving one example, you can imagine a family taking an autonomous shuttle, the parents inside, kids outside, the vehicle drives away or vice versa. That is, of course, a complete no-go. And if these things happen once or twice already, then the acceptance is going to drop rapidly. So this is something which we need to address carefully already at the beginning. So there's some tasks in autonomous vehicles, entry and barking, debarking activities, which we have to screen very carefully before we go real life.
Mm-hmm.
Okay, I would like to address as well the complexity of the different scenarios. So I think in the transition phase at the beginning, we will have some, let's say, easier scenarios, maybe slow-moving vehicles, last mile, maybe also in areas that are well suited for such activities. But imagine some cities where you have old towns or a city profile that's maybe not perfect for some automation, maybe because the infrastructure is not properly set, and then you get some acceptance problem because then the vehicles are very slow, or the vehicles stop at some point, or they cannot bridge some gaps where you need then another mode of transportation. And I think for that transition phase, we will also need some support and see what is acceptable and what not, for not damaging the new technology just as it fails at some points.
Mm-hmm. Yeah, thank you. Yesterday, as I said in the introduction, we were discussing a lot about added value, new added value through new components. This was very focused, of course, on it was very much focused on the electrification. Yesterday we were talking about electric motors, about batteries, about fuel cells. I think the technological changes which are coming with the automatization and the connectivity, we already discussed it after your presentations a little bit, but I think the challenges are much broader than through the electrification. So for companies in Baden-Württemberg, as we are a region which really has grown and really has a very good market position in combustion technology, but if we look at the companies in Baden-Württemberg, so what are the challenges, maybe the opportunities for companies to go into connected and automated driving? Are there new components coming up which will be coming to the market? Are there new challenges, Alexander? Maybe.
Yes. Thanks for the question. So I would like to go from the, let's say, the powertrain. There are also challenges, but I would go really for the automation. I think there will be new or should be new activities towards sensors and also computation platforms. So I think what we see today, that the sensors that are highly sophisticated and used for current, let's say, experimental aspects of automated driving, but also then for the market, still are quite pricey. And also from the perspective of the computation platforms, I think there will be much more edge processing, at least the pre-processing where the data are created, instead of providing everything to a central unit. But also for such architectures, we need new solutions that can be sold on the market and that are efficient. And what we've seen, so in the last discussions, that there are not enough chips for the cars. Mm-hmm. I think that is something that will develop in the next time. And I'm interested also to see how we can support such activities for really having the innovation, but also the products here at Baden-Württemberg, mm-hmm. and not having strong dependencies to, let's say, Asia, for example, mm-hmm. to get such components.
I mean, from the U-Shift, you both are involved in the U-Shift project. This is a complete new concept of vehicles. So,
for me, it's a déjà vu. Mm-hmm. Roughly 10, 15 years ago, we started in Germany to deploy Industry 4.0. And for the big companies, it was already a struggle to get this implemented. For the small and medium-sized enterprise, it was at the beginning a disaster. There was no manpower, not enough brain power there, expert missing on a large scale. And this I see again here in this activity, trying to make mobility 4.0. We still miss the brain power for this. So we need to qualify small and medium-sized companies to take the pace which is necessary. It's going to happen fast, but still be in contact also with the OEMs. The OEMs will define the pace, and our task is definitely to ensure that the small companies don't lag behind.
Yeah, maybe I can add, because you asked for the U-Shift concept, for example. I think this will be also a great opportunity for companies coming up with new ideas. If you look at the capsules, which are part of this traffic concept, even if you're not part of the drive board, you can think of very many different capsules which you can provide and offer for different services. an office capsule or whatever you can think of. So I think there are also great opportunities which you can have. And I also agree with Alex that sensors is a very important topic, and also the electronic control units for the vehicle, which have to be very energy efficient on the one hand. But as you have seen from all the talks here, I think we all integrated infrastructure as information somehow. So there's also a great opportunity in developing new sensors, control units, and so on for the infrastructure side. So it doesn't have to be on board the vehicle necessarily.
Ulrike, in RABus project, you're working together with ZF. You mentioned, so maybe it's a new role for a supplier who is in this case much like an OEM itself.
Yes, ZF becomes an OEM at this point because they are the ones together with to get there, getting the shuttles on the street. And I think what they really need are the testing kilometers. They need the data. They need to really see how the shuttle drives on the road, how it is connected to the infrastructure, and how it's maybe even speaking, let's say like this, to the people surrounding it, because just because the shuttle knows it's going to stop, how do the people on the street know that it sees them and that it's actually going to do something to stop? So we really interested in this kind of data, and we need to use that to improve the system, and especially in a project like this, give the opportunity to others to use these data as well. So.
Data is a good word, is a good point. Yesterday we had a part of the panel discussion exactly 24 hours ago was really about the whole topic of necessary data. Of course we had I think FZI is also involved in the KISME project that Dr. Scheer explained us yesterday. Of course, you need data, you need to analyze data. Artificial intelligence can be a method to analyze this data, but of course, we already talked about the legal framework, then we have data protection regulations, we have security issues and everything. So maybe let's talk about this whole connection of, also again, opportunities and maybe just a few threats for the whole development. Maybe we start with...
Thanks. Yes, so as I've shown in my presentation for the test area, what we do, of course, have is plenty of sensors. And especially when it comes to GDPR, the video sensors are problematic. However, if you think about AI, meaning most likely machine learning in the past years, you need data to train something. And now we would have the challenge, okay, on the one hand, it's a technical challenge because we can produce so many data that we cannot even store them. This means we need to be selective, and we need to take care about the GDPR. But for example, if you would say, okay, you're using some measure to grant privacy in stored data, but later on you would like to use those to train something that is related to the human individuals. For example, to train something about intentions of pedestrians. But then you cannot train it based on some pixeled images of the faces or so. So this is something where also we from the research side need to provide measures. On the one hand, how to deal with the big data. On the other hand, how to use them afterwards, because often if you could store the raw images, you do not have even an impression what you would do with them maybe in 2 years. Mm-hmm. And that's why you cannot use them as they are, and then you need to take some measures for the privacy, and then maybe you're reducing the value of the data you have.
Yeah, maybe I can add that I think the start, having the European regulation on privacy makes the start now a little bit harder for each of the partners working on that data, like Alex said. But in the end, I think we will come out of this with very good solutions which respect the privacy of the users. And I think in all over the world, if once the technique is established, all the users will ask for privacy. In the beginning, if it's something is new, it's cool, you want to try it and you don't ask for privacy. But if you're using that regularly, privacy becomes more and more an issue. You see that in the States, but you see that also in Asia, for example. And so I think this is even if it's like a barrier in the first step, I think it's a good starting point for the follow up when the technologies are established on the market. So I don't see this as a big problem. It's a challenge for sure, and we have to handle it as a research institution together with our partners from industry, which doesn't make it easier if you have different roles in a project to share data, for example. But you find solutions for that. It's time consuming, and you have to discuss with lawyers and all that, but in the end, I think we will find solutions, as also Alex said, we will, and on the technical side, we will also find solutions how to store the data. We cannot store everything, but we will have measures to select which data is important and which is not. And this might also be, using AI to decide what is important and not. And then we will store that in a manner that it respects privacy for the users in the end, I think.
Maybe it will be a part of the RABus work with the users, of course, that, always the question, I want all the data of the others to plan my way, but I don't want to share my own data.
Yeah. It is important to communicate what we actually want to do with this data to the public, because if we just keep it to ourselves and then maybe at some point we just say, oh, here's a camera, just for your knowledge, that won't bring us to the acceptance we are looking for. We're really looking for showing them what kind of CCTV we have installed and what the CCTV is actually recording, and how we maybe even blur some kind of areas just for everyone to be safe or to feel safe. And then to show them what the benefits are, because this is the same with when you're using your mobile phone and device, and you have this app, and the app shows you what you can actually do with all the data you give them. This is what we're gonna try to do with RABus as well, that we try to show what benefits come from giving us this data, so that the vehicle gets more and more safe and secure and is reliable at the end.
I mean, at the moment, there are a lot of political, industry, research-driven activities to gather data in data spaces on the European level. Gaia-X is one word, and a few weeks ago there was an announcement. Now it's called Catena-X. It's an activity to gather more production-oriented data, really like a data-driven value chain. There are activities bringing together research data. How important is it for you as researchers to have these data spaces? Maybe
of course, it's important to understand the data. Adding to what my colleagues here just said, especially Ulrike, trustworthiness is one big question here. What we have is not the first time that we look at automation. We have automation, fully autonomous flying already in place. We have autonomous public transport on rails in place. And there we already have CCTV. We have CCTV in stations, in airports, inside the underground trains, etc. And there's not a discussion about these CCTVs currently because they're trusted to a certain extent. They provide security. And we have to take the same step forward in automotive applications. We also have to ensure that the same way how it is used in public transport on rails, it's going to be used in public transport on cars as well. Then we already have taken a biggest hurdle, next step there. Data is more important on road transport because road transport is more complex. So the analytics behind this require even more data. We have more scenarios than on rails, rail is just two-dimensional. In the cars, it's really three-dimensional, what we have to focus on. So the artificial intelligence we put behind this is much bigger and requires, for statistic reasons, also more data. So as researchers, we definitely need more data, but on the other hand, we have to deal with this data as well as we dealt with it in aerospace applications and rail applications.
Okay, then maybe I'll take the chance. So I think it's also, apart from how to use data, it's also an efficiency question how to provide data. Because if you look back into the past before those initiatives existed, everybody who needed data had its own infrastructure and its own interfaces between the tools and ways of storing it and ways of querying it. And everybody did the same, but it's not compatible. And now that's also what we saw. So before we had the test area, also at FFZI or data repositories for training some neural networks, for example. And now you see this effort with the test area, and there are also other partners and other experiences. And I think if we achieve at least to get there some standards, maybe not just to share all the data, but at least how does a data repository look like? How does a query look like? How does a meta description of the data inside a repository looks like? Then we could also have some innovation steps, because then there could be some companies that would offer their services, their digital adding value based on those standard interfaces, and could ease up for the people or for the companies who are just interested in that it works. They don't need their in-house scripts for each and everything. They don't need their own IT making backups of the databases. But if you have this, let's say, common interfaces and common language, common architecture, then you could also have an efficiency gap removed, and you could have additional added value.
Yeah, standardization we discussed yesterday, and I would have a question to Michael. You are in an European project, ICT for Cars, as you told us, and one point of the discussion yesterday was that it's for companies who work in an international way. It's sometimes really a problem. I mean, of all the regulations on data protection and data security are on a European level, but one point of the discussion yesterday was that the interpretation of these regulations are quite different in different parts of Europe. Do you have from your project any experiences in that? Or?
No, we didn't encounter any problems with respect to that, because our architecture, as I presented, processes, for example, the camera data directly at the sensor, and all the data which is transmitted has no privacy issues anymore, because it's just the position, the speed, and the size of the vehicle, for example. And this is the same also in the Italian test site or in the Austrian test site. And because you mentioned standardization, we use standard ETSI messages, for example, for that case. But we also see that standardization is I mean, it's a research and innovation project. So as you probably might know, it's that what we offer as a service within that project is not yet standardized completely. So the messages don't fulfill everything we need. So what we always do in those projects at the moment is to push the standardization forward. For example, for the collective perception message, which is the environment model from either a vehicle or the infrastructure, we are partners of the ICT for Cloud project. Together with our input, are part of the working group working on those standardization, because we need to push that forward and to also further develop. You need standards to be compatible also between different OEMs, also between, if you have older vehicles on the road, they still have to be able to use that data once we think this is already established. But then you will also need a process how to add new services and to change the standards to develop them further. And this is also something which happens at the moment, largely in this area where the message is used for communication between the different communication partners in the infrastructure and on the road it's ongoing, it's further developing. You see new versions or new drafts every 1 or other year for the different messages, which is good.
Just one other point I would like to discuss with you, as you are all representatives from the research sector. It was a topic yesterday in all discussions too. One strength of Baden-Württemberg is always said is the people working in the different companies and in the research institutes. One point yesterday was really that the whole in the education in the universities has to become more flexible and adapt to all these challenges that the technological change brings about. And of course, another question is how to qualify people working in the companies today who have studied some technical topics a few years ago and are now working on combustion technology or other things, how to make them fit for the future. So I would be interested what your opinions, or maybe just especially your experiences about these questions are. So I would start with Ulrike.
Yeah, so at the University of Stuttgart, we also already came up with some new studies concerning automated and connected driving or autonomous systems, so that we get the new ways for the students so that they can study in these kind of fields. And there are often studies where few institutes came together, so it's not mainly our Institute for Autonomous Systems, but it's also for the informatics and so on, because the students, I think, need a broad range of knowledge. We can't just deep dive into one topic and then leave out the rest, because that's not what they're going to do in the future when they're working as well. I personally see the problem even further when we're gonna see the transition that's happening, and we're gonna have to come up with some new ways to bring the people who are actually involved in the internal combustion at the moment to give them insights why it might be good to change over to the electric vehicle or even to other fields as well. So I think we already started with it at the university, but we have to come further into the companies as well, so that we can teach the transition there as well.
I mean, I have a very dedicated personal view on that. I think it's very important, and one of our strengths here in Germany, and especially also in Baden-Württemberg, is that if you did your studies in electrical engineering or mechanical engineering or computer science here, what you normally got from all the universities here in Baden-Württemberg is that you have a very broad base. And this allows you to even make all those transitions, because you have the basic knowledge on a broad field, and you're not a specialist in a technology that might be old in 5 years or so. So and this is also a strength. When I did some internships abroad in Canada, for example, during my studies, this was something which the people there didn't expect, that you have such a broad basic knowledge, and you can discuss with different people in teams with different people, and you understand what they're saying, because they have very specialized studies. So I don't think the solution will be to have very specialized programs at the universities. For sure, we have to add as soon as possible the new technologies to our curricula. But on the other hand, we still have to remain the broad basis, which allows the students to dive deeper during their life after university in different topics which will change, because the basis, maths, engineering basics and all that, these stay the same. Communication technology, for example.
So the secret is a broad basis to stay open-minded.
Right. That's my point of view.
What are you?
Yeah, I can add to this. I personally see a big dilemma. What we have here, we all talk about long life development, learning the whole life. So it means also that we have to ensure that people already in the industry have a chance to learn. On the other hand, when I collaborate with OEMs or small and medium-sized enterprises, people are working 120% of projects. Have limited access to kind of additional classes, additional lessons learned to take. That gives the challenge that they are left behind also after a while, working only inside companies. Where I try with the boards of the companies to ensure how can we take them along, how can we take them ahead. And this is also necessary to be done here in Baden-Württemberg, definitely, yes. The other thing, like Michael said, is the in-depth knowledge is not so important anymore. It's a broad knowledge. So what I do when I give lectures, I take the example of my field, of the vehicle domain, but then I teach my staff dilemma management, for example, Six Sigma tools or engineering tools, how to solve system problems. I talk about cultural awareness. So things which broaden the view and enable the students to take any kind of tasks in the near future, because the world is so volatile, so quick changing, that they also have need the possibility to adapt as quick as possible.
Alexander? You?
Okay, yes, I would also like to pick this point, and I think we need some kind of mind shift. Because currently we have a really development where at a broad level we have changes in the industrial structure. You cannot compare it with maybe the beginning of the 80s when the computers came up, but it's now really some disruptive changes that need a broad adaptation. This means on the one hand the mindset needs to change, let's say on the executive business level, to see, okay, there are some new technologies, why not address them and why not send people explicitly to learn something new? On the other hand, we also need the mindset of the employees, because even if you're 120% in the projects, you always need to say, okay, my market value may change, because in the area where I'm an expert might not be sufficient, although I have this broad basic knowledge, but there should be some, let's say, latest high-tech things maybe I should deal with. And that's also, so we are from FZI, we're not directly giving any lectures, although we have the relation to the different universities in Baden-Württemberg. However, what we did is for some, let's say, latest technology findings we have, but that are so mature that we've proven the industrial applicability, we provide some specific trainings that could be hands-on training with 4 persons, or maybe some hands-on workshops with up to 20 persons, really to offer what is from our perspective, and it seems that it's requested from industry, is relevant for them to, let's say, at first maybe just test whether a technology might fit to what they aim to do, but at the end also to have some larger scale training of the employees.
As we have a new state government coming up, maybe for you as representatives of the research field, what are necessary steps for a government just to make the universities, the research institutes fit for? Is it really like framework for funded projects, or are some measures to make it easier to work on qualification of people working in companies, or any ideas that we can now communicate? Michael?
I mean, what we definitely need is a good balance between the different fields, and I think what is especially important for universities, which I would say is a basic funding for the university, which also allows for basic research, which is not directly already an industrial project. So in the last years, we have seen that most of the funding comes from research projects in large projects. You get more money if you are in projects with industry. But the basic research, as we had in electrochemistry, for example, for the batteries, I think in Baden-Württemberg, there were only the last professors in electrochemistry when the batteries came up. So this was a good thing that there was a basic funding also for fields which did not seem very promising to that time, but there was some basic research on that, and this quickly developed into a large branch. And I think we should retain that, and we need enough funding for the universities to allow for that basic research, which is then added by the research of the other research institutes like the FZI or DLR, which are more industry-oriented, and this has to go side by side. But in the last years, we have seen that the basic funding for the university here has decreased compared to the other funding, and I think this is something you should work on, because then you're prepared for the new technologies coming up in, I don't know, 10, 20, or even 30 years.
Yeah, maybe to add, from 2004 till 2017, I was a member of the board of the German Industry Association for Research, Innovation, Technology. And what we saw there is that Germany in general is very well set up for basic research, excellent universities, very qualified work being done. And then we have a very good industry as well. But we see that lots of what has been developed here, innovated here in Germany, has been moved out of Germany for then industrialization into Asia, for example, or even to North America. So we were not that good in Germany, and still are not that good in picking up what has been developed, innovated here into our own industry. And that is where we need help of the politics to bridge that gap. So really to enable us with demonstrators like RABus is, like U-Shift is, to define and see what technology readiness level is necessary to do the implementation, in the real innovation step, the final innovation step before it comes an industrial product.
Maybe I can add that the current situation, for example, if you have a research project which has a good idea, the current legal situation to start with a startup after a research project is very complicated, because I mean the professors, for example, might not be allowed to be part of that startup because they have their association to the university. There are laws that forbid that. The knowledge is at the universities, and they have to. By law, they have to any company, even if it's a startup, to pay for the knowledge the university has, so that you don't have some money going to industry without control of the European Union. And this is something which makes the startup community very hard from research projects, for example. Correct, yeah. And this is something we have to, like Tjark said, we definitely have to gap. And this is a legal problem on the one side. I mean, the laws have their right, because, I mean, we don't want to have corruption on the other side. But at the moment, it's very, very complicated.
Actually, that's a perfect hint to our afternoon session concerning startups. We will discuss with some of the startups in our network, and these are all types of founders, some very young one, but also a little bit more aged. And, that's always a tricky question about finding the right environment to foster startups in Baden-Württemberg. We had that for several years. We have about 2 minutes left, so I would like to come to a short conclusion round. Our former Chancellor Helmut Schmidt once said, if you have visions, you have to go to the doctor, not in politics. Luckily, we are all not politics, so we can try a little bit vision out. So I would like to picture what do you think will mobility look like? You mentioned mobility 4.0. This was my idea. So what do you think will mobility look like in 2050? That's 30 years from now on.
For me, it's important that we still have mobility also for not so rich people. So mobility for everyone. That is at least also based in our fundamental laws we have in Germany. And our task is to enable and keep this going ahead. This is one thing. Secondly, what is important, we talk about decarbonization, environmental footprint, etc. That is only a goal, but the means to it is that we reduce the energy consumption, also in mobility and in other areas as well. So focusing on reduction of energy while providing the mobility to everyone, that would be my vision.
Alexander?
So I think for me it's less mobility. So I think some good thing we learned from the Corona situation is that not each and every business trip is necessary. You don't need to be in office every day. The second point is where I also agree, I hope that mobility will be affordable. This means everybody has access to it. And the third point is I think it will be more or less without any combustion of fossil fuels.
Michael?
I mean, now it's hard to add any new points because you, Alex and Jörg already made almost all points. I also agree that mobility even has to be more inclusive than it's today. It has to be a mobility for everyone and it should enable everyone to be able to consume mobility. But I also agree with Alex that the consumption of mobility has to be reduced if we want to have this energy reduction what Jörg was talking about. So I agree with them.
And last but not least,
I think we should see mobility as a service, and we should really look how we can make it affordable, but still ways to choose from, which is maybe the best way to travel for the people and what kind of transport they're going to use, but without using their own personal car, because as we know, it stands around for, I don't know, 95% of the time. So this isn't really a nice vision for the future, because we could save or we could use this space for anything else in the future.
So, thank you very much to all of you. I say thank you to Dr. Alexander Viel, Professor Dr. Tjag Siefkes, Dr. Michael Buchholz, and Dr. Ulrike Weinrich. Thank you for your interesting presentations, for the interesting discussion. I would have liked to go on, but we can do this at another time. So yeah, at the moment we just reached the point of lunch break. We are, as I said yesterday, we are still working on the 3D replicator to bring you some lunch at home. So concerning your lunch, you will be on your own. We will come back to you in 1 hour at 1 o'clock with the already mentioned startup session. So yeah, thank you. And yeah, see you after lunch. Thank you.
Thank you.
Thank you.
Baden-Württemberg?
No. Baden-Württemberg.
Baden... Was?
Baden-Württemberg.
Baden-Württemberg.
So, hello again. Hopefully you enjoyed your 1 hour lunch break. We are back with the e-mobil Baden-Württemberg stream as part of the digital version of the Hannover Messe in this year 2021. We're glad you're back with us here with a very interesting afternoon session. Our whole stream has the title New Mobility Made in Baden-Württemberg, and for this afternoon we decided to take a look at new generation value creation. So Baden-Württemberg is not only a place for very well-known and already quite old and established companies, but also for a lot of interesting new companies. And as we take a short look back on our program, which we had since yesterday morning, we were talking very much about the different changes that coming up with electrification and digitalization of the mobility. So if you electrify all kinds of vehicles, of course, which we already did, we discuss about electric motors, about fuel cells, about batteries. Of course, you need the necessary charging infrastructure, all these topics. We already discussed a little bit, but we will now see that it's also a field not for only established companies, but for a lot of new companies, and of course, if you take a look back on the session this morning, we discussed the whole field autonomous and connected driving. So there, one aspect, for example, was that it's very important to deal with all the data, and data is necessary for all kinds of new mobility solutions, and we will come back to that as well. And yeah, one point that we are always discussing, transformation, as I said, we will face, due to these technological changes, we will face a transformation of the automotive sector and of the whole mobility system in Baden-Württemberg. So it makes necessary for the established actors, for the established companies to transform themselves, but it brings a lot of possibilities for founders, for new companies, and we are really happy on our virtual booth in the Hannover Fair, our virtual Baden-Württemberg pavilion, to give this platform to some very interesting and exciting young companies from Baden-Württemberg. And the first presentation, a warm welcome to Dr. Markus Schiefer. He's the founder, executive director, chief technical engineer of a company named Skimo, Elektrische Hochleistungsantriebe GmbH. And we're looking forward to the presentation, and afterwards we can discuss some things more in detail in the panel discussion. So, Dr. Schiefer, the floor is yours.
Yeah, thank you, Mr. Fischer, for your kind introduction. As said, my name is Markus Schiefer. Together with two colleagues, we founded Skimo in 2017 after we finished our PhD studies at the Karlsruhe Institute of Technology. Skimo is designing, manufacturing, and testing electric drives, mainly inverters and motors. But today I want to concentrate on the motors, and especially the winding technology which makes those motors so powerful. For everybody who is not so familiar with electric motors, I want to show the basic principle of motor first, so that you see what we are talking about if you're not so much into electric motors. So this is a random view, a section view of an electric motor. So it has nothing special to do with the winding technology I want to talk about later on. It's just to show the basic principle. We have a rotor, and for the electric motor, this is the only rotating part. And if we are talking about the most popular machine types for traction applications, which is the permanent magnet synchronous machines, we also have some magnets mounted on that rotor. And surrounding that rotor, we have the stator, which is non-rotating. And the stator is made of electric steel laminations. And in those laminations, there are some slots, and in those slots, there are insulated copper wires, which then form the winding. When we then excite those wires correctly, then with an alternating current, then we are getting a torque or force generated on the rotor, which is then rotating. We also need some other parts in that motor, but what I want to highlight is that the basic principle of an electric motor is relatively simple. The whole construction is relatively simple. And when we are thinking about e-mobility, that's probably the reason why everybody is talking about batteries, about charging, about other things, but not so much about the motor. But if you want to make that motor more powerful, more efficient, and less, and at lower costs, or if you want to make them suitable for high speeds or for really low speeds, for direct drives, then the things becomes really complex. It's so tricky because the electric motor, or all electric motor manufacturers have the same technologies, the similar winding technologies that are well known. And everybody is using copper as electric conductor. Everybody is using steel for flux guidance. So it's not so easy to make a difference. So the questions that I came up with is, what can we do better? How can we significantly improve that electric motor? And Simo developed a unique patent-pending winding technology that significantly increases power density, significantly increases efficiency. And as we are using the same materials that all other series motor manufacturers are using, we can significantly reduce the amount of material, and therefore we can also reduce the material costs themselves. With these motors, the car racing team of the Formula student team of the Karlsruhe Institute of Technology became world champion in 2016. With these motors, we set a new world record for ground vehicles in the SpaceX Hyperloop pod competition. Elon Musk was slightly pissed off after that because he wanted to re-break that record again, and his Tesla-based pod caught fire on that attempt. In the year 2015, the company Siemens announced that they had set a new record for electric machines and that they achieved 5.2 kilowatts per kilogram continuous power density. We are achieving 10 kilowatts per kilogram continuous power density, which is almost twice of that. But we are only using cheap standard materials for that. In the year 2020, we were awarded by the European Commission with the Seal of Excellence. So what are we doing different to make those motors so powerful? We are not using round wires like the other electric machines in the last 100 years did. And we are not using solid conductors like the at the moment very popular hairpin winding is using. We are using really thin flat wires. And with these flat wires, we can achieve high filling factors. We get an excellent heat transfer from the winding. And we achieve really low frequency-dependent losses. But we need a totally new winding process. And if we compare that to a standard automotive OEM traction motor, we see that we can achieve 50% higher power at a quarter of the weight and at the same efficiencies. And this is a real motor type which is really tested on a test bench. And just have a look at the weight comparison. The 50 kilos come to the 30 kilograms, and you will get an idea of how many material costs you can save with that. So, but the question is, can we produce this economically? And the answer to that question at the moment is no, not yet. So at the moment, we are still manufacturing those motors on semi-automatic winding machines. But we have a demonstrator of a fully automatic winding machine that already showed that the whole winding process can be fully automized. And at the moment, we are working really hard on getting the first series motors done on that, or winded on that fully automatic machine. Because, as I said, the materials costs can be significantly lower. This winding process is the key to be the state of the art, also for costs. So we think that we get really competitive compared to the state of the art with that process. But this was about costs. There are a lot of applications where you really need high power density. For example, in sports cars, especially in electric flight. And this is just like are some motors that should show you what we can achieve with that technology. So we can achieve, as I said, 10 kilowatts per kilogram continuous output power with standard materials. We also did a study for larger electric aircrafts where we could show that we can achieve 6,000 Newton meters at 1.2 megawatts continuous with a motor weight of 200 kilogram as a direct drive. This might seem to be a really unique application, but the technology itself is really suited for direct drives. So it's also suited for commercial vehicles, for heavy-duty applications, and for railroad applications and other things that really rely on direct drives. If you're looking for high efficiencies, we can achieve efficiencies up to 98%. If you look at high-speed generators for energy, at spindle drives, or flywheels or other applications where you need really high powers at high speeds, we are building a motor at the moment with 200 kilowatts continuous power at 30,000 RPMs. And we can also build a motor with 70 kilowatts at 70,000 RPMs, just to give you some ideas. This is the management board. All with deep knowledge and university background in their field. And if you need a motor for your application where no motor is available on the market, just contact us. I think we have an interesting solution for you. If you are a company with expertise in production and going to market, and you want to precipitate in that in the new electric markets and the chances that they offer, we are open for partnerships. If you are an investor and you are looking for new green technologies that really make a difference, together with you, we can scale this up even faster. Thank you for your attention.
So,
Baden-Württemberg?
Non. Baden-Württemberg.
Baden... Was?
Baden-Württemberg.
Baden-Württemberg.
So we are back. We heard the first presentation of our startup session from Dr. Markus Schiefer from the company called Skymo. Now we would go on and pass the word to a second startup. So we will hear Dr. Schiefer again later on in the panel discussion with all the startups. So this was very, a special component of new mobility, the electric motor. Now we are more going into the data space, as I mentioned before. We say hi and a warm welcome to Dr. Thomas Freudenmann. He is the co-CEO and co-founder of a company called EDI GmbH. Thomas, it's good to have you here, and we're looking forward to the presentation about EDI.
Yeah, thank you for the nice introduction. Thank you that we can be here. Yeah, welcome to my presentation. My name is Thomas Freudenmann. I'm the CEO and co-founder of EDI and EDI Engineering Data Intelligence. The name is here program. We like to semantically link the data and provide AI-based decision models to support the engineers, but also to automate machines, or in the case of this presentation, also the vehicles. And what we have built up, it's a platform, it's called EDI Hive, so that we really can provide digital products for our customer. And this platform, it means we have a framework where we have a lot of standard modules already integrated. So we have a user and right management system included, because data security, data privacy, it's a hot topic also in Germany, also in Europe. And also we really keep care about this topic in our company. But also we have a lot of algorithm already integrated as standard modules to analyze data, to store the data, and to work with the data. And one of our business case is that we can bring your company logo and your corporate design to our platform. So that means you can sell it as a digital product. And also we have an application framework so that we can really develop in a fast way new applications, and we can use here standard modules so that we be able to have a fast return of invest of your product. And we are coming from the semantic web. So when we make our PhD, so my colleague Dr. El Hachi and I, we were focusing on these knowledge management systems and how we can reuse engineering data in an efficient way. And all we guys know from the Google, it's easy to find information. So now we are located here in Esslingen in this virtual booth of the Hannover Fair. But for me, it was really easy to come here and to find it. And I get the map here, and I get also the opening time of this location. So that is what we get from Google provided. And in a company, in the most cases, we have to search for files, and we have to know that something is stored somewhere. And exactly this is where we're working since more than 12 years on, that we automatically find relevant information and we provide the right decision to the engineers and use it, for example, for better products or for automate machines. And one other main focus from our company, it's AI. Artificial intelligence. So I think everybody hear about these words. So I just want to give an interpretation from our side what a real AI is for us, or what it means for us as to have a real AI. So there are a lot of different machine learning algorithms available. And in the most cases, if you talk about AI, you will hear deep neural networks. But also, you have to keep in mind that there are a bundle of other machine learning algorithms which are really strong for other data. And neural networks works really good for images. And I think also there it's a good tool to use and a good algorithm to use. But also we are working on time series signals. So there are a lot of other algorithms available which are really good to use. And the most important thing is, if we are work together with small companies where an expert is standing since 35 years in front of a machine, of a process, or also if he runs a machine, so he has a lot of knowledge in mind. And also in the companies are some strong simulation tools available, and also to integrate this information into the data algorithm, then you get a real AI because you include the business logic into exactly this algorithm. And I think that's an important thing, and that's exactly when you can make right decisions. And that is what we are doing with our toolbox of different machine learning algorithms, but also we have a patented technology to integrate this expert knowledge in our algorithm so that we get a real AI and we really make the right decision, which also supports the engineers and automate the machines. Our platform is also cloud-based, so there are a lot of cloud-based platforms available, and I'm really happy about this because that means we can integrate really easy. So we also partner, for example, of Siemens MindSphere. That's the IoT cloud environment from Siemens, where if you have a Siemens machine, but also if you have other machines, you can store really easy from the shop floor the data in the Siemens MindSphere. And then companies like us, we can analyze the data, and it's really easy to get access to the data. And that's the good thing of cloud technology. It's not about the storing place, because also we are working since more than 4 years together with the Daimler AG here, located in Stuttgart, next to this nice building here. And we are running with our EDI Hive platform framework on the Daimler Hybrid Cloud. And in this case, we provide management applications to make the product differentiation so that the people know which kind of parts they can overtake and which they have to produce new, and where we get where we need new tools to produce the parts. So this is, we are run on the Daimler Hybrid Cloud. It's an intra-server system with the same cloud technology, which we are also using for our customers, where we are hosting everything, for example, on NetWays or Strato. And this works because we are basing on Kubernetes, and that's why it's really easy to integrate. And we really believe in this ecosystem of different platforms that they are working together. And you can deploy your solution in different environments, and that's also one of our business, that we deploy our services in the environment which our customer wants to have. So now I want to focus on the autonomous driving stuff. So I was skipping one slide, sorry. Anyway, so yeah. So we keep you safe on the road. So I was skipping this important slide. We keep you safe on the road, and therefore we developed a dynamic risk management algorithm. And we can use the dynamic risk management algorithm not only for autonomous vehicles like a Google car, which out any driver. We also can use this algorithm for the development of this kind of systems, but also for conventional cars or for navigation. For example, if you are driving on a bicycle. And how this works, I will explain in the next slides. The basic of our algorithm, and that is what you can see here in this video, we analyze a lot, in more than 100,000 critical incidents which are recorded in the area of Tokyo in Japan, and which are labeled manual from experts which are at a university, and they give a label. For example, there was a pedestrian crossing the street, it's at night time, but also we have the information, for example, if the pedestrian was recognized the taxi or not, or if the pedestrian was drunken. So this kind of labels we find in this database, and that's really important and powerful, because based on this we can analyze the driving context when critical situation happens. And also we get from the experts manual labeled the level of risk of each situation. And based on this algorithm we train our AI, and also we could show 2 years ago now on a conference in US that we can use our algorithm, the dynamic risk management algorithm, which also include a driver model that we can find the right speed in different situations. And we coupled it with the PTV Vissim simulation environment from the PTV group. So PTV is also located in Karlsruhe, where EDI is from. And we could show that this algorithm works. So that means in the simulation environment, we could give the driver of PTV with him, we could give the information from our dynamic risk management algorithm, and then the car was driving in the context with the right speed, and we could reduce the accidents and also the critical situations. And the most important thing about our dynamic risk management algorithm is that we have a prediction how probably is that a critical situation happens, and then we reduce the speed before we are coming in this situation. So our dynamic risk management algorithm is not an emergency brake system assistant. So we help with this algorithm to find the speed much before something critical happens. And this algorithm we can not only use now in the simulation or in the car, we can also use this algorithm to identify on recorded situations if a critical situation happens or not. And here we automatically find out in a Berkeley data set, for example, this critical situation, which appears because on the right side it's a construction site, so there's no space, so the driver has to brake really hard, and we can analyze this situation now with further AI tools to find out what was exactly the reason and how an autonomous vehicle should behave in this kind of situation to avoid critical situations. So in this case, we can use the algorithm to analyze automatically recorded files and figure out where is the interested part, for example, where we have to optimize our autonomous vehicle functions. And this is exactly where we also use this algorithm in a founded project called Rely Risk Estimation with a learning AI. EDI is here in the lead of this project, but we have strong partners with Fraunhofer, IOSB, which is also located in Karlsruhe, but also Fraunhofer, IAO, and University Stuttgart is working together with us here in this project. They are located here in Stuttgart. And a company who brings these things in the simulation, and it's also a really well-known company. It's IPG, with the IPG car maker. I think a lot of people who are working in the automotive area knows this company, and also this company is located in Karlsruhe, and this company is founded 40 years ago as a spin-off from the KIT, so EDI is founded 5 years ago, as well as a spin-off, so we have some way in front of us, but we are really happy that we can work together. And also you can see here as an associate partner, the e-mobil organization, so we are really also happy that we are in this community because it's a strong working together, and also we can see here on the event that this communication and cooperation is really helpful. And also, and that is what I said, we can use this algorithm not only to develop better systems and to certify these systems, we can also use this algorithm for a safe navigation. And this is a project which was is started in beginning of this year, and it runs 1 year. It's founded also from the Baden-Württemberg government in a special project. And also here we have strong partners with Fraunhofer from Freiburg and Innovex from Karlsruhe and Cargo. It's they are producing heavy bikes which you can transport goods. And for these guys, it's really important to find a safe road to deliver the products to the customer. And exactly therefore, we can use our dynamic risk management because we can predict which road it's in a special time of the day, more dangerous than another road, and we can not find the fastest way, like Google Maps is doing it for us. We can find a safe way to the destination, and that's a new dimension of navigation. And I think that's a really nice project where we start here, and also the output of this project can help planner of cities that they can make safer roads. So also this output, it's really relevant. This is why PTV group, it's also included in this project. Yeah, so at the end, I mentioned we are also a spin-off from the KIT, so we are 5 years old, or more than 5 years old, 5.5 years old, and we are now 22 people from around 14 different nations. So we are a really international team, and yeah, we have many customers, so from the region like Daimler, and also we work together with Siemens, but also we work together with customers from Korea and Japan. And yeah, I can say thank you, and also thank you that I can have my presentation here. And if you are interested in our product, so for data analytics stuff to empower your development, or if you are interested in these mobility solutions, please contact us. So we are really happy to work with you together. Thank you very much.
Thank you very much, Dr. Thomas Freudenmann from EDI, telling us about your company and about artificial intelligence and all the interesting topics. Would have been an interesting part for our today's session in the morning about automated driving too, but then we do this next time. So I'm looking forward to the panel discussion later on. And right now we skip, thank you very much, Thomas.
Thank you.
We skip to the next presentation. Our next presenter cannot be here with us today, but using all the digital possibilities, he's there digitally. Warm welcome to Dr. Markus Imsen. He's Managing Director of 52 Technology, is the name of the company. We're happy that you join us in this session. I give the word to you, to your presentation about virtual materials.
Thank you very much for a nice introduction. Thank you for having me here. And I think we can start now with my presentation. I hope it works. Should be soon visible. Yeah. Okay, so directly we jump to the first slide. So we humans are great in envisioning things like aeroplanes, and we are not only great in envisioning these things, but we have also the engineering power to construct, actually build these things and overcome the fundamental laws of physics or use them to then achieve great mobility. And so we as 52 are a company who's providing software tools for engineers that they can create even better tools and engines. Yeah, we are located in Freiburg. We are founded 6 years ago. Now we are almost 30 people, and we are relying on strategic partner, sales partner for the automotive industry. We are working very closely with AVL, which is also distributing our software, which is called PreonLab. You see here our customer, a logo wall where you can see that we are more than 90% of our customers are coming from the automotive industry, and they are using PreonLab in various different ways, which I would like to show you in this presentation how what you can do with PreonLab. Therefore, first of all, we would like to look at a nice example which should come now on the next slide. Yeah, so here we have this nice car and this nice automatic opening of the trunk, which works very well and is user-friendly in most of the scenarios, but there are some scenarios which it might cause some problems. And so we with PreonLab are able to simulate different fluids, including snow, where you can test your vehicle and different parts, components of this vehicle in terms of how it interacts with these materials. So here you see a complete simulation done with PreonLab of the same scenario, where you could, in a virtual environment, test how the car will interact, or what the consequences will be when you open the trunk, when there's water on top, when there's snow on top, or even mud. all simulations, videos, animations that you see in this presentation are done with PreonLab completely. Also, the visualization is done in PreonLab. Here you see a planetary gearbox, which is performed by a customer of us without any training. So we focus on very user-friendly software, lean workflow. If you have the CAD data, then you can import these into PreonLab, and you can set up the scenario in PreonLab and do the simulation. Coming now to a use case, this how, for example, Schaeffler is using PreonLab for optimizing the lubrication concept of gearboxes, especially for electric engines where we have very high rotation speeds. You see here on the right-hand side the task. So we want to increase, or Schaeffler wanted to increase the oil flow into the upper channels, and these for all driving conditions. So the idea of the engineer was to build this oil deflector, this plastic device, and which should then help to pump or to keep more oil flow in the upper gallery, in the upper channel, such that the cooling component of oil here is also satisfied. But the question is, what is the optimal design? And not only for one driving condition, but under all driving conditions, different speeds and different temperatures. So we come from a very big design space, and if you have this virtual tool like PreonLab, you can already in the very early development stage test this virtually. And really, these simulations were run overnight so that the customer could simulate the different designs and test the different designs, and then choose for the optimal design from the simulation, which was then built and later on was verified in the test bed that the mass flow increased by a factor of 6 for all different conditions. So in one of the previous slides, I've told you that our USP is usability, but it's also efficiency, where we are by far faster than traditional methods. Traditional simulation methods are grid-based methods. We are using particles. So we are a spin-off from the University of Freiburg. I have more than 10 years of research done in the field of particle-based methods, and these particle-based methods have some intrinsic advantages. Together with the research of our team and the R&D work been done in the last 6 years, we are now able to do things that are not possible with traditional methods. One other example and use case is water weighting. Here, the user is interested about the water level in front of the HVAC system, for example, or the underbody forces, especially important for electric cars, where you have the battery packs on the lower part of the car. In traditional methods, which you see on the left-hand side, the car is stationary and you change the reference frame, so the water is flowing around the car, not the car is driving through the channel, which is the case in real world. With the particle-based method, you can do this. You can really drive the car like in reality through this channel. You have the rotation when it goes down the slope, and you have the rotation of the wheels, and more importantly, you have also the suspension of the car can be modeled, and it really reacts due to the underbody forces, which you see here on the left-hand side, the comparison of the simulation to, in the bigger picture and the smaller picture, the real-world video. So, and on the right-hand side, you see the comparisons. Orange is the simulation prediction, and the blue line was the real-world measured data for the deflection of the spring mass. So this matches very well, and there's also master thesis by Volvo where you can get more details. So reliability, of course, for such a tool is very important, not only for this big volume of water, but also when it comes to smaller amounts of water, where we have also microfluidic behavior. Like here's a test bench from IAV, where they tested the capabilities of PreonLab and other tools with respect to this test bed. And on the left-hand side, you see the simulation results. Again, simulated completely and visualized with PreonLab, can be done by the customer since we provide presets. And on the right-hand side, you see the real-world test bed. So there are also data that we can show or which you can find on our website, as well as for this Renault example, where we show, or the customer has shown, that PreonLab is capable to predict really microfluidic behavior and can be used to for safety reasons when it comes to oil leakage, where this oil can come into parts of the car or shouldn't come into parts of the car where it causes inflammation. And yeah, the user can just use presets or define the physical properties like surface tension, viscosity, and then he gets the real behavior of what he can do in a real test, but in virtual reality and at a much earlier stage in the development. So flagship applications in the automotive industry are sensor soiling for water, oil, snow, or mud, where you can optimize your sensors, your camera positions, especially for autonomous driving cars. We have water weighting. We have seen this lubrication optimization, or for gearboxes, and a newer application is e-motor cooling. So we can also simulate the heat transfer. And what is very important here is, so PreonLab differentiates from other products in its efficiency, in its reliability, and its usability. So it's designed not only for the CFD engineer, but also for the engineer in general. We have many users that are coming from the testbed, have years of experience on the testbed, and now doing these tests in a virtual environment. And due to the high post-processing capabilities, so we have really this renderer which can render these photorealistic images, the results can be well communicated to the designer and to the manager for efficient decision making. And we see here room for improvement for the future by bringing this also into the cloud, into more faster access from everywhere, and increase the tangibility, the insights by more reality using virtual reality devices or augmented reality. Thank you very much for your attention. This is it for my talk. Talk to you later in the panel discussion.
So thank you very much to Markus Imsen from 52 Technology for your interesting presentation. This was our third startup presenting. We are just going straight to number 4. I'm happy to introduce you to Johannes Boführer, the CEO and founder of a company named Eliso, caring about charging infrastructure. So Johannes, it's good to see you in person again, and we're happy to hear your presentation about your company.
Thank you very much, Wolfgang. Yeah, my name is Johannes. I'm a founder and CEO of Eliso. I'm in electric mobility for quite a while. So I started 2008, and I've been in different fields like battery technology, power electronics, and charging infrastructure, and with different companies like Siemens, Volkswagen, and BMW. In 2016, I started my own business. I decided it's time to start a charging business. So I started Eliso in 2016. Eliso is a full service provider, a charge point operator. So we do the planning, the installation, and the operation, the daily operation of charging stations. When we talk about charging stations, I think it's important to understand that the charging station is a very important part of electric mobility. If there is no charging station, there won't be electric cars. And the number of charging stations is growing fast, and this is good. And also, major OEMs announced many electric or plug-in hybrid models for the coming months, and this is also a good sign. And I think both parties need to keep up speed that there will be a lot of charging stations and electric cars in the near future. So when we talk about charging stations, there's usually a question like, what should we do first? Is it more important to have AC chargers or DC chargers? And I think this is a very important question, but there is no right or wrong. So both is right. We need probably both more AC charging stations and more DC charging stations. To do that, I did a survey on LinkedIn, and I asked some people to participate. In the end, I had 400 participants, and I was asking, What should we focus on? Should we focus on low AC charging points with up to 22 kilowatts, and we can do a lot of them? Or should we focus on 50 kilowatt DC charging, where we can do a few or some? Or should we focus on high power charging, and we can only do a few? And the surprising result was it's even. So there was now really a focus, and 400 industry experts did not have a common opinion, like this should be the one thing that we focus on. So we got 35% on AC, 30% on DC 50 kilowatt, and 35% on high power charging, which surprised me. I personally think that on the DC side, on the high power charging, we already are making very good progress. So I think I would focus on the AC side. When we talk about charging power, I think the time that a car is parked should determine the charging power. So if the electric car is parked for, let's say, 6 hours, I would recommend an AC charging point with 11 kilowatt. If the car is parked for, let's say, 30 to 60 minutes, I would recommend a DC charging station with a 50 kilowatt. And if the car is parked for less than 30 minutes, for example, on a highway, I would go for high power charging up to 300 kilowatt. So that is my personal opinion when you think about putting up charging stations or charging points. So what is cosmix, and how does cosmix relate to charge points? Cosmix is Europe's biggest platform for charging hardware. We established it, it's online since 4 weeks, and we've been working on it the last year. Only because there are so many manufacturers on the market that offer hardware products, and every month there's a new market player coming up and offering a new product. And we as Eliso, we act hardware independent. So we don't have one single supplier. We have a portfolio of hardware that we use for each use case. And that's why we had to manage a portfolio of suppliers. And probably as many others, we started with the Excel sheet, and we put all the data in the Excel sheet, but it soon got bigger and bigger, and it was kind of difficult to keep it up to date. And since there are many suppliers, but these suppliers have different products, and these products have different models, and these models, they have different options. So even if you think you have like one AC wall box that is your favorite, there are many, many varieties. So we decided to put it online, make a platform, and we call it Cosmix. Cosmix is Europe's biggest platform. Right now we have over 700 products online and available. You can easily compare these products because you can save time instead of typing in Google and searching for products and downloading product sheets and trying to compare the arguments. You can go on Cosmix and you can filter those products. We have 140 technical criteria that you can just click on. And then you can, for example, you can say, I want to see all the wall boxes that have 22 kilowatt charging points and have a display and a certain kind of RFID communication. So you just click on those arguments and the platform will show you all the products that fulfill your requirements. So comparing and finding charging infrastructure is much more easier on Cosmix. Also, we believe that more than 700 models is more than any Excel sheet. So just the amount of products is just much bigger, and it's growing every week. So since we are online, we already onboarded 2 new manufacturers, and we are in close contact to those manufacturers. So anytime a new product is on the market or a product is changing or some specification on a product is changing, we will update it on Cosmix, so you will always have the latest and the newest data on charging hardware. And this is important for all the people that are working with charging hardware. We are online since 4 weeks, I mentioned it. We've got very strong interest. We have already a lot of users, and we've been in a workshop with the major OEMs that are always telling us that this has been missing. There has not been one single source for charging hardware so far, and now there is this platform, Cosmix, where you can find all the manufacturer, all the products, and you can save a lot of time. You save a lot of time searching and comparing those products. This platform is also not only for us. We made it to have a stage for all the manufacturers to present their products to customers like us, because we believe that it will not get less, it will get more and more. So every quarter, every half year, there will be a lot of new products on the market. So it will get more and more complicated to manage all the products that you are working with. So why would you save and manage an Excel file and store it on your local computer if there is a single source that is always available online and it is always updated? So in our sense, that doesn't make sense. That's why we actually did it for ourselves, and we got so much request that we published it, and now it's available for everybody. So if you're interested, we have a free online seminar on April 22nd. And if you want to join us and see that here you have on this slide, you have a picture of the platform itself. And on the left-hand side, you can see all the criteria. And on the right-hand side, you see the products with pictures and all the specifications. As I said, on April 22nd, we have a free online seminar. And we will present cosmix and the advantages. So join us, follow us on LinkedIn to stay up to date. And don't search for hardware, find it on cosmix.
So, I actually noted the date, 22nd.
Very good.
Very interesting for our team as well. Thank you very much, Johannes. It was Johannes Brotführer, CEO and founder of Eliso. We will talk again in a few minutes in the panel discussion. So thank you much for presenting Eliso. And then we have, last but not least, the next presentation. We stay in the field of charging infrastructure. A very interesting company as well, named Charge IQ, and the co-founder Stefan Dengler is with us. A warm welcome to you, and we're looking forward to your presentation about Charge IQ.
Sure. So let's start. Hi, my name is Stefan. I'm from Charge IQ, and I think you'll see the screen now. Yeah, today I tell you how sharing EV charging station generates value for both owners and users. And first, some words about Charge IQ. Charge IQ consists of 12 employees, and we were founded last year, and we have some first technology proofs from pilot projects I'll tell you later on. But what does Charge IQ do? What's the thing we offer you? Our goal is to make charging infrastructure accessible and easy payable or billable. And for example, I'll show you this picture. Some weeks ago, I went to the courthouse in Stuttgart and I tried to charge my car, but there was no solution to charge it. So I asked the house technician and I tried to charge it at a charging point, but it didn't offer me any solution. So I noticed that even today, our charging infrastructure is not as intelligent as it should be. Another solution was my co-founder Tin. He tried to charge at our new investor, and you can see in the background there is charging infrastructure, and you may think, okay, why is this guy charging at a Schuko plug-in? The thing is pretty easy. There was no access for him. There was no possibility to give guests access to the charging infrastructure. And that's exactly what we see what's the problem. The public charging infrastructure, which consists of maybe 20% of all charging processes, gives you really good access to all the charge points. But the thing is, the 80% in private or semi-public area does not. There is no easy access and no way to bill it. And that's exactly where we act. So how do we create more and better available charging points? The first thing is we make infrastructure accessible and give access to third parties and people who doesn't really originally belong to this charging infrastructure. The second thing is we offer you the possibility to expand your charging infrastructure easily to give access to more charging points. And as a third point, we see the integration of renewable energy, which is really important in the future to get rid of all, let's say, fossil energies. In in the last time, we had some different governmental programs where we checked our solution and we noticed one big pain point. And this is the already mentioned access and possibility how to build, how to get easy access to different charge points. So I'll show you now a graphic where we started our pilot project. It's called Bürgerladenetz Baden-Württemberg. And this takes place in the really rural area in Albstadt-Sigmaringen. Here you can see some public charge points, which doesn't look so bad. But with our idea, we call it the Airbnb for charging infrastructure. We integrate all the private and semi-public charge points that take place to our network. And that easily gives like 150% more charge points. And that's our product. We say we give you a user management to give access to your own charge point so that you don't get charged or get a bill for your own charging process. We integrate all the roaming partners that like the EMPs, the electromobility providers, get access to your charge point. And we do all the payment and billing process for you, that you can sell the capacity of your charge point to others, to thirds. And as a service, we put in your charge point into different cards and maps, so people see how much is the price, how much, what's the opening hours, and about the status. Is it available right now? And the big aim we see is that we don't have any hurdles for you. For example, there is no extra app you need. There is not a community thing. We say access must be granted for everybody. Another thing is we don't need you to have a user account, and we don't see there should be any like fancy currency. It's cash only. But we also have some hurdles that we face. For example, the first is we have some pretty interesting reporting requirements to different stakeholders. Another hurdle is the balancing group management. Also the EEG levy, which is especially in Germany pretty interesting. And the conformity with calibration law. That makes it, to be honest, super hard for you to share your charge point, and that's where we come into play to solve that problem. And how does all of this work? Here you can see our dashboard. With this dashboard, it's pretty easy to get connected to your charge point, and we offer you like different solutions. For example, one is this product called ShareIQ to share your charge point with different others. And here you have some advantage of the solution. For example, the economical aspects, that it's easy to earn money if you just give the capacity you don't need from your charge point to others. For example, I'm here right now and nobody needs my charge point at home, so others can use it. Another thing is the financial aspect. It's the most efficient way to sell solar power to thirds than putting it into the grid. Another thing is the competitive aspect. If you have more charge points, there is like an effect in terms of the supply and demand. So it's easier to have cheaper prices and help e-mobility, which is another big point, the idealistic aspect. We see a lot of customers that only want to push the e-mobility and say it's a good thing if we have more charge points. Which leads me to the last, to an environmental aspect, that we reduce the usage of fossil energy sources. And in a nutshell, that's all. Here you have like a little overview of our team. At the moment we are 12 people, and that's like all the points from ChargeIQ so far.
Yeah, thank you very much to Stefan Dengler, co-founder of ChargeIQ. And this is the end of the first round. We talk again in a few minutes in our startup panel discussion coming up next. So we need just a short break to prepare the panel discussion, and we will be right back. So, hello everybody. We are back with the panel discussion in our afternoon session. We heard 5 very interesting presentations from some upcoming young and very interesting companies from Baden-Württemberg. And now we have the possibility to discuss a few points more in detail with the presenters. In our panel discussion, I say hi again to Dr. Markus Schiefer from SkyMo, Johannes Brotführer from Eliso, Dr. Thomas Freudenmann from EDI. On the screen again, Dr. Markus Imsen from 52 Technology, and last but not least, Stefan Dengler from Charge IQ. I would like to start with some starting round. As I said at the beginning, one point of transformation into a new mobility system, of course, is that existing companies have to transform, have to change themselves. But very important, however, of course, it's that we have the basis for founding and establishing new young companies with innovative ideas and business models. And of course, it's always been to a focus in the political point of view to create some sort of startup culture here in Baden-Württemberg. As you all founded a company in Baden-Württemberg, I would be interested if you can share your thoughts. How would you describe the startup culture as you found it in the last years in Germany, especially in Baden-Württemberg? So what were your experiences, the opportunities, your challenges when you just for yourself decide to start with a company? Maybe we start with Dr. Markus Schiefer.
Okay, yeah. I would say for us it was a big advantage that we came out of the university, of the Karlsruhe Institute of Technology. So we had a lot of things that we could already show to the customers. We already had, or were successful to get some funding from exist funding from BMWI and later on from Baden-Württemberg Junge Innovatoren funding, which is a really good support to start your business, because you are not so, you do not have to deliver like in the first month or so to earn some money. As we have products, I think we scaled up really good so far. Maybe it's a little bit more difficult than in other countries, like in the US or so, to then really get to the larger fundings, or it's a little bit more difficult probably to get to private equity and so things. But on the other hand, the support from the government and so on is, I would say, quite good.
So just to the other founders, I mean, Thomas, you also founded your company from the KIT as a starting point.
Exactly. So also we get a lot of support from the KIT, and before we were starting our company, so I have 2 colleagues. We are as a co-founder. So we are working on a technology transfer project, where also the invest was coming from the KIT directly. In this case, we were employees from the KIT, and after that we were starting this project. And I mentioned in my presentation that we have a patented technology. My colleague Dr. El-Hachi and I, we are the founders, and we can use it in our company. So that is what the KIT has. One of his pillars is the innovation sector, so they really want to support these young companies. And also this was for us a good starting point. And then we will also have from the PhD, so if you are working in the PhD, we have a really scientific focus. But in this technology transfer project, we were also working with a department from the KIT, which already have the focus on the market, on the business. So you also change your language, you change how you can come to customers. And that was really helpful for us. And also, I agree. So sometimes it's hard to get the big invest like in US, to get 1 million to run your company. So even you have a good idea, I think it's hard to find this kind of investors in Germany. We have examples where also these kind of startups are possible in Germany, but it's not so much. But on the other hand, I will really say that in Germany, we have a lot of good also funding programs, and also in Baden-Württemberg especially. So we working in the digitalization, so we want to help also the small SMEs. So in Baden-Württemberg, we call these companies hidden champions. And also for the hidden champions, they get some funding from the government, which they can give to companies, to startups like us, that we can bring the digitalization also for these companies, that the solution happens there. And I think this kind of investment structure, it's also really special in Germany and better in Baden-Württemberg. So also we work together with companies from different states in Germany as well. And we here in Baden-Württemberg, it's much easier to get some kind to invest in the future mobility, but also in the digitalization in general.
Yeah, thank you. Maybe we just pass to Markus Imsen. I think you mentioned in your presentation also that the starting point of the company was in this case University of Freiburg. So what were your experiences founding a company with a university background?
Yeah, that's right. So we are from Freiburg, University of Freiburg. We have received the Exist Forschungstransfer, and actually then that's about it with respect to funding. I would chime in here and say, so getting venture capital is probably a bit harder. We have never gone this route, and even if we would have get a lot of money from venture capital, I think the problem for us would have been to build a sales network, a global sales network. So even if you want to build this on your own, and so a lot of automotive manufacturers, OEMs, are in Asia, and also there we need to have a lot of customers in order to win the market share, to grow sustainable. And so I always think if I would have had this money and then go there and had to have someone in a position to be like the global sales officer or a local sales officer in Asia, I'm not sure if I would be able, coming from the university, to understand and have a good feeling of if this is the right person and if we are on track, especially for a young product which has to prove in the market. I see this. Therefore, we have gone the route with having a sales partner, a strong partner from the industry, where we have a product which this partner needed in order to grow their sales in the software business, and we rely on this network. I think for us this was a very good win-win situation.
Thank you, Markus. I mean, the other two founders, they followed a little bit a different path. Johannes, you mentioned that you had several stations before. So when was the point where you said, okay, then I decided to start my own business? So what was the motivation then to say you worked for several companies and then to say, okay, now it's the point where I start my own business?
I think the point is where you notice that something is not going well or you can do it better, and that's the point where I decided that I want to start my own business and do things better and be the creator of something. And I was born and raised in Stuttgart, so for me it was never a question to found my company somewhere else. But I've been told, or people told me, you should go to Berlin. Berlin is where all the startups are. But honestly, I would choose Stuttgart again because on the sales side, for example, we have so many industry and companies in Baden-Württemberg that our clients are just in front of our door. So I don't have to search a lot. It's right there. And also we have good universities and good schools. And for myself, I can say I have fantastic employees. And so it was not bad. Maybe Berlin is more fancy and you have other investors. I found investors in Stuttgart. So I would say it's not impossible. But maybe they can be a little bit more brave and they're more conservative, I would say, but not in a bad way. They're reliable. So I think that's something good. I wish they would be a little bit more brave and more brave.
So Stefan Dengler, you also worked at a car company, I think, before. As we had to talk over the first technical problems at the beginning of your presentation, we talked a little bit that your co-founder, he used to work for an IT company. So what was your point saying, okay, now we start our own business?
Exactly the mix we just heard. I also work for a big OEM in Stuttgart. And I thought, okay, it's not bad here, but I think I can do more of it if I start now something what I'm working for. And I think the area for founding companies right now is pretty good because it's also the exit story we had, and then it's pretty, I don't want to say easy, but it's not that hard to get like an invest by different programs here. And the feedback, especially here with different people from different areas, from IT and automotive area, is extremely good. They're super creative people also working in a ChargerQ that have pretty good ideas. So I think the output that we gave to different people is like exactly what they want to hear, what they think is or could be the future.
Yeah, so to sum up, thank you very much for sharing these motivations with us. Just to sum up, okay, we have a good economic and university landscape here in Baden-Württemberg. When we as e-mobil Baden-Württemberg, when we discuss with different parts of the state government, there's always the discussion when should the founding and the supporting of young companies should stop. It's okay. You already mentioned there are some supports in the pre-seed phase and the seed phase. So it's always you already mentioned, Marcus, at the beginning. Okay, sometimes a little venture capital could help, but it's not really quite necessary. So there's a lot of discussion in the last year going on. Do we need more venture capitalists in Germany? That's actually not part really of our financing sector till now, or is there other supports, especially in this growing phase that you have as a company? What are your thoughts, your experiences about that? Maybe we start with Marcus again.
Yeah, just one founding program that is probably well suited for like a little bit larger larger startups are in the European Union programs. So they are really for scaling up in like 1 to 2 million budgets, numbers. So there are other possibilities. I would agree with you that there has to be some point where you say, okay, it cannot be that it's only funded by public funding and so on. On the other hand, you gain customers, you gain contacts with industry, and then on some point you can stand on your own foot, and then you want to go that way. Yeah. And for really scientific things, when you really there are a lot of other funding instruments really if you want to go then in future ideas and like more. Yeah. Not so much development, more like really trying out new things. Then there are other things that you can rely on. Yeah.
Mm-hmm. Yeah. So maybe I already mentioned that from our side it was a really good, I will say also opportunity. No, we not get directly the money from the government. So our customer get the money to enter in new market, in new technology. And the advantage for us was that we have to reflect already as a young company to the market. So we are also a private owned there. So from our a group of 3 founders, and we are private owned. But we start our company, we really get the customer because they get also the money from Baden-Württemberg, for example, with the digitalization voucher which they have, and then they have the possibility to give it to us. And I think this cooperation it's really helpful in case that you, as a young company, you already reflect to the market. And I think that's one important thing. Compare also if you have a lot of money available. So we also so if you get a lot of money, but you not really understand the market, then you also not know what you have to do with the money. So I think the good thing also in US, it's not only that you get money, you get also sometimes this kind of business angels, which you also get the advice what you have to do with the money in the right way. But that makes also sometimes hard if you run a company and you have your own idea and you have an investor in your company and you have to do what he wants to do, then maybe you can also stay at the big OEM. Yeah? And then you have also to follow this kind of rule. So I think this combination that you have to reflect really early at the market, I think that's also a really important point in the invest from the state, because if you invest too much a starting up company, then maybe the reflection in the market it's not the right way.
So it's not really a business angel, but partnership is a key word. So I would come back to Markus Imsen. You described your partnership with AVL. So I understood, as you said before, it's good that you can more or less focus on the technology, and as a young company, you have not to focus on all the aspects. Can you tell us a little bit more what the advantage of this kind of partnership is?
You phrased it right. Very good, I think. So the 30 people working here, they are mainly focusing on developing the product. We're having a software product which is licensed by the customer on a yearly basis, and AVL is doing first and second level support. So we do only the high level support, and software usually the costs in software usually scale with the sales and the support, right? And so therefore this partnership help us to grow the company, let's say at a reasonable costs, and I think it's a very good model to scale. Also, we have very good context to the market. One thing I like to mention here is what was surprising for me. So in the early days, we were doing sales on our own. Is everyone we talked with said it will be very, very challenging for you to get entering this automotive market, but actually it was not that challenging. I think what is very good, especially here in this area, is that there are many big OEMs and that they are also very open, I think, to new technologies and to small companies. This I found very, very good. But maybe this is something that about the locality here, and for going international and growing internationally, a partner who has already their departments there and the context to the market and can support the customer in the local language was key for us, I think.
Yeah, thank you, Markus. Just to go on with more partnership, networking is I think very, very useful. Johannes, as I remember, I think one of the first or second time as we talked, and that you told me your idea about Eliso. It's really a few years ago already. I think I remember just say, okay, have a look at our cluster network. There are a lot of different companies in there, a lot of research institutes. Is networking a good thing for a young company, just to broaden the perspective you have on your business idea?
For sure, yeah, that helps a lot. And joining e-mobil BW was a big step for us, so thank you again. And it was good to have partners and also clients. So we made at e-mobil BW, we have partners and customers and clients, and so that was for us was a good move. I think networking is always important, and it's never bad, but it does not make your sales. So you still have to do normal sales and normal sales process. So I think organizations like e-mobil BW help a lot in the beginning and later on. That it doesn't get less important. But I think when you're very in the beginning and you're trying to find your business model, and I think we already have good programs where you can challenge your idea and find your business model. But as soon as you skip that phase and you ask for subsidies or funding, we made the experience that it was kind of difficult because there was always one requirement that we didn't fulfill, and then it got like annoying that we always applied and never got the funding or the subsidies. So we decided we do our own path. We don't rely on subsidies. We find our funding with investors, and so we did, and that worked well. So I think for beginners or for startups in the early stage, there are very good conditions. In the medium phase, where you are growing to a small business, there could be a little bit more subsidies, more funding, and then later on, money helps. It might sound simple, but money helps. And if you want to grow a company really big, I think there are investors in Baden-Württemberg and Stuttgart, and they're good, but there could be more, and it could be more attractive for them to invest.
Yeah, that's a good point. I would come to Stefan. And again, about this thing, as Johannes described, networking, partnership, maybe customers. I mean, as you just explained, the idea of Charge IQ. So you saw, a certain deficit in the whole field of charging infrastructure. But of course, on the whole field of charging infrastructure, there are a lot of major actors. I always discussed it at the beginning with Johannes too. So how is it is it difficult to really identify just the way to come into this like a growing market?
I think it's not only competitive, it's only cooperative. I think with Johannes we had a talk 2 years ago, 3 years ago at your office. It was really big, now it's really small, I guess. And that's like the thing that's worth a lot, because people are open to others. They like to talk about ideas. They think, okay, there might be a business opportunity. Also talking with you or with Business Angel, with accelerators. I think you can have the help if you want to. And people here, especially here, they're all the time they're open to your ideas and to have a conversation with you.
So actually, we are on the way to my next question, but I really, I don't know if you can answer it fully, because we have to keep, of course, a little bit of secret. But really, what are the ingredients of the recipe or to start a successful startup and to transform the successful startup really into a running company? Because at some stage, of course, you let the startup behind you, and I mean you already said money helps, but what are really the ingredients? Of course, you start growing. You need you need good people working for you, and you need organizational advice and things like we already discussed a lot of points. But what are the main ingredients you would suggest, Stefan?
It's interesting asking the youngster first. So I think it's worth a lot to talk to other founders, to have a conversation with them, to see what's working and what's not working. And especially in this special networks in Stuttgart we have, there's also a lot of conversation with these founders, which helps especially me a lot to see what could be a failure and what's pretty worth to be done.
Maybe Markus Imsen. It's very. I know from the other side, it's very difficult to follow a discussion where everybody is in one room and you are the only on the screen. So
I'm sorry for that.
No, it's great that you joined us anyway. So
no, I'm following. Thank you. I think team is very important. I think it was mentioned by the others also in their talks, and they highlighted their team. I didn't in my presentation, but I'm very happy and lucky with the great individuals that are working here. And so I think at the beginning, you need to convince the team about your vision. And they need to buy in this vision and work for your company with you in this team. even though maybe other bigger companies are on paper more attractive. And persistence, resilience, I think is very important. Not to learn that success is not a straight line. There will be ups and downs, and you need this belief in what the others also said, that you can do something better, or that there is some chance that you can do as a small company much better than a big company because you have more focus. And then you need luck at the end, I think.
Thomas?
Yeah, so what I can say, and also that is last year with Corona, so I think for everybody it was not so easy, but we were a little bit lucky because we were really established also our working process before Corona appears, and then for us also this home office stuff was not such a big problem. So everybody knows that we are making software, so we are follow Scrum, but we really establish also the processes. We have our teams now ready. We have all these meetings which you need, and we established this before Corona was coming. So then we could also go in the home office. But I think the team is important, and we are growing. And if you start with 3 founders and everybody have somehow the same ideas, then you can push really fast your first products, and you can also show that it works. But if you have 23 people, then everybody have to understand what you want to do. So that's really hard to communicate also this message and this information to the whole team. And I think that is one of the challenge which everybody have to face in the growing phase, that everybody follows the idea, and also that you have at the end, you need a robust product, because in the beginning, everybody knows you are a startup, but also the expectation of your customer change if they are seeing that you are older, that you are bigger, that they want to have from your product. And also this, I think that goes hand in hand with establish some kind of more processes, then you also get this robust product. And that is what we also faced in last year, and that is also for us really, I think that's an important step for all the teams if you are growing. These steps, so I already hear, so if you go over 50 employees, if you go over 100, it comes again and again, because you get new lines in your companies where you have to handle somehow with your processes as well.
Yeah, I kind of understand that. I mean, e-mobil BW was founded more than 10 years ago. Last year here, we celebrated our 10th anniversary, and we started with a very few people, and now we reached the magical border of 30 people in the team as well. So you need to, as you described, it was a good description. You need to define processes and everything. Johannes, money helps. Okay, I remember that. But from your perspective, you already told us a lot. But the main ingredients.
First, you need to have a good idea. I think that's the start, and then you need money. Money helps. That's true. But both are not the most important ingredients. I believe it's team, timing, and execution. So those are the factors that make it a winning or failing. And so for us, all we achieved only because our fantastic team. So I wouldn't have done it by myself. So all the progress relies on a great team. Timing, you have to be on the right time in the market. You can be too early or you can be too late. So timing is, I think, another factor, and execution. So you can have the biggest plans, you can have a good idea team, but if you don't execute in the right way, and that's what you also mentioned, you have to adjust the execution to a small startup with 4 people or 20, 50, 100 people. So being able to adjust and execute in the right way, I think that is a really important factor on being a successful company or not.
Yeah, many things have been said, but I would say at the beginning, you have an idea or a product, it depends. At the end, you need a product and customers that pay for that product. And if you're selling products or services, depending on your business model, and you earn money with that, then you're on your own steps at one point. And the beginning to go in the market, it is difficult to know what your customers want. In our case, for the motors, our first customers were really big companies. And it was more like research development thing. Now we are going more, as we grow up, more into like medium or smaller sized companies, and they're much more conservative, or they have some expectations, and then you have to fulfill all those expectations or like specifications. And it again makes a lot of work. And at the beginning, you need a certain money, funding, a certain amount of resources to really get over this first step, to really meet that expectations for the first customers. But then I would say that the customer can also pull you if they request what you have, then everything is working fine. At the moment, I would say in the Corona crisis, we see that a lot of smaller companies, they are really limited in spending or like in investments, because everybody's like a little bit careful, and that like if you have a really special product like we have, we somehow see that there's like less it's a little bit more difficult than it was like before Corona crisis.
Thank you. As I did in the morning session, I mean, we have an upcoming new government in the state of Baden-Württemberg. We will have elections on the federal level in autumn. So it's not Christmas time yet, but you as young entrepreneurs, if you had one wish free to the state, what would help? Maybe the wish is just stay out of our way. We are managing it for ourselves. But is there one point where you really think this would help if the state would act like this? Stefan?
Yeah, sure. There's one wish. I recently talked to our Prime Minister, Winfried Kretschmann, and I said this wish, and I said it's the EEG that stops us.
Okay.
And that's my wish, just stop the EEG.
Maybe we can back to Markus Imsen for your wish.
Good question. Never thought about it, actually. What the bottleneck is from government side on us. I think I'm coming back. I thought in the beginning, in the early years, it was quite difficult. Liquidity was a problem, and then like taxes. Maybe they can support younger companies better, therefore. But this is not like fully thought through on my end.
Other wishes or?
So I have a wish. So I know that data security and privacy is really important, but I think we need a change in looking to these things. So we saw it with the Corona application. I think the Corona application, it's really privacy, but if it's also safe in our time, I'm not sure. I think there could be better solutions. And I mentioned our project Rely Risk Estimation with the Learning AI. We have a test field in Karlsruhe, and here it's not allowed to have high-resolution cameras on a cross-section to train algorithm how pedestrian behaves if they are crossing the streets. And we not want to know who is this pedestrian. We just want to generalize and finding out how we can make our systems better. And I think there are also involved research institutes with Fraunhofer and all these things. And it's not possible to work with this kind of data based on the privacy. And I think there is a change in the perspective is needed, so that if you agree that you are working in the best way, that you work so that the privacy is kept and all the security of the data is kept, then I think it should be possible that this kind of data are available. And I think that would be, for me, a really big step in different projects to open the mind and looking to data and privacy, what we need in the product so that we have a safe product, for example, also with the Corona application.
Mm-hmm. Johannes, you are in charging infrastructure as well as Charge IQ. So is it more or less the same wish, or is data really an issue in your work?
Data is an issue, and I actually do not agree to that wish. I mean, I know that law, and sometimes it helps, sometimes it helps not, but that would not be a wish for me. I do actually not rely on politics or do want to blame the system, I encourage everybody just follow your path, believe in your idea and fight the obstacles, and that is actually the way to go, because politics can change and your business should not rely on politics. So that is my opinion. If you want to do something, I think you should encourage young people to found a company, and that could be with like support in a consulting way or in a financially tax-wise, so that it's not a big risk for young people to start a company. That could be something, and there are different actions to do.
Marcus, you are more really like developing electric motors.
Yeah, but I mainly have to join those wishes. So I cannot add one really. So I would say that the government itself, the whole thing makes a good job on that. So there are a lot of instruments that you can use as a startup. There may be some more general wishes, but this is more for like general economics or like maybe a culture thing or so. But at the end you have to be on your own feet at one point, and then this should work. And
I'm not sure if I remember right, but I think one or two of you mentioned always, one thing that politics is often thinking of. What are your experiences with all kind of accelerators, hubs, and spaces where different startups and other companies can work together? Is that an interesting approach, or is it really like Johannes said, just follow your path? Don't care about the others.
I think what I said. So I didn't really believe or rely on those programs. They're good for some. We didn't participate in any of these programs, and we made it very far. So I think it's good for some, and some that need it, they should do it, and for the others, they can go their own way.
I think with the hub, so especially if we talk about digitalization and AI, what we are doing in our company, there are so many to find where you always have to be member and such things. It's also for us hard, and also for our customer, which are using or which they want to have a product which is made with AI. It's really hard to find the right cluster and these things. And I think sometimes if you have too much, so I think it's also costs a lot of money to have these organizations. But then if it's out too much, then also the people lose the focus. So I think. So as e-mobility, I'm really happy also because this is an organization which is really helpful. So also we have a lot of contacts there, and we get also new customer. We get also big projects based on a coffee break at e-mobility meeting. So that's really important and helpful. And this is why I also think that this kind of cluster and organizations are helpful. But also to have a focus also from the government side, it's I think really important. And to found too much this kind of organization, I think the effect is bad in the case that the people lose the focus.
To be honest, this is a discussion we really often have within the cluster management or with some partners which are very long and very long years in a part of the cluster. It's always, of course, we really like having startups in the cluster and developing, but it's always the advice for them. Just use the offers that this network has, which are really useful for you, and focus on your idea, and do not try to participate in everything. So what are other experiences?
Yeah, I don't agree that much, to be honest, because we took part in 2 accelerators, and now we are in a 3rd accelerator, and it gives you contact to really experts in their special branches, and it helps you to sharpen your product, to take the customer view, and to give you a view from different sides, for example your IP or your finance, and At ChargeIQ, I'm responsible for like the economical parts, and I studied this, but I'm not like really confident with some special things I have to do every day, and that's where those accelerators helped me a lot. And I think especially for really young startups, for groups that are just forming, it's worth a lot.
Markus, has 52 been part of an accelerator or something like that?
No. I have no experience in that. As I said, so we have, we had this Exist Forschungstransfer, and this was great. And from there on, we focused on our path. As Johannes said, I can second his experience, but I also can imagine that there are other routes which work. I think this is more an individual thing, and I'm happy that they are there. But for us, this was our way until now.
The other Markus, Skymo.
So many accelerators like I saw them. So we also did not really join like one of the external accelerators. I think sometimes they are more in that idea phase. So generating an idea, looking if it could succeed on the market in that step. So I think we started behind that. So we had a really detailed product or a view of an idea of a product that we want to bring on the market. What I sometimes find interesting also, I do not have a total solution for that, but sometimes I think that it would be interesting if you have on the one hand those more traditional small companies that are good in production and all those things, but not so much in generating new technology and so on. And you have the startups with really new technology that also really, maybe want to focus on that technology. And sometimes I think if there would be a good way to bring those worlds together, I think that may be some interesting thing. And maybe the government could support us. On the other hand, e-mobil is something like this because it brings companies together.
Yeah, actually, this was a discussion we had always because someday some of our ministries said you have to take care more of startups, and we said okay, we are doing it anyway. We care about interesting companies, no matter how old they are. Before we come to the final round, I would like, we already mentioned that once or twice, but I would be interested what your experiences, I mean, especially the COVID crisis was really heavy for all companies, but I can imagine that as a growing company, just starting your business, what were your experiences in the last year? Thomas, you already mentioned a little bit.
Yeah, so I will say for us it was also helpful because we could bring our product more aligned. So we also get we get also in the beginning trouble. So some customers, they also closed because of Kurzarbeit. So it was also these projects were still standing, but we already know what we have to do that we get better out of this crisis. Okay. And so it was not the problem of workload what we had in this year. So we could also push our product in the last year. That was also helpful in this case. But for sure, I can also say, so in the beginning where nobody exactly know how everything works, so also some support from the government was helpful in the beginning. So we also were starting 2 months with Kurzarbeit, not full, but so that we also get a little bit, I will say, brief to look how everything goes. But then we get also some new projects during the crisis. So then we could stop after 2 months with these things, and then it was helpful. Yeah. So also I can say for us it was really also the reaction was really fast. So we hear a lot of critical things, but also I think everybody have to understand that suddenly 90% of all the companies are looking how everything works. So nobody knows exactly in March 2019, 2020, sorry. Yeah. nobody knows exactly what happens next. And that was, for us, what was the government was reacting really fast in our case. So it was helpful with this, first possibility, so that we get a little bit more relaxed, and then we could also use the time to increase the quality and our product in the right way. So that was a good thing from this last year.
So Johannes, I remember, I think last year in May or something like that, we spoke on the phone. There were the first 3 months of facing the COVID crisis. What were your experiences the last year?
Well, I think in March it was kind of shocking and a surprise. I think we adjusted very fast, and that was good. We also have been using Kurzarbeit 50% for some weeks. But also we have been colleagues in using, our colleagues are in Germany all over the place, so we have been used to remote work before, so it was just within a day we've been able to just continue working. Our customers partly were also like holding their money back, which I cannot actually understand. But overall, looking back now, 1 year, we made it pretty good. And I think, as you said, the government support was fast and good. So I think for my company and that industry, we actually we survived that phase very good, and the outlook is pretty good. So all the projects that have been postponed last year, they will come this year, hopefully. So,
Marcus, for Skymo.
Yeah, when we look back at last year, also thanks to the funding that we have, we made huge steps in our automating of our winding technology, which is really a good step. And so we had no Kurzarbeit last year, which is we are quite proud of. But at the moment we have two kind of businesses, like more the research and development, really they're looking for what is possible with electric machines for new applications, and the more traditional applications. And at the end, in both, there is you see a lot of requests for those products, but not so many contracts like you have normally, like we are used to before. So the smaller companies or more traditional businesses, they really are not sure where it is going, and they have an overall. Also, their customers are probably like not buying so much, and also for the research in some areas it's really good, but in some areas research was really cut off because some markets really declined massively.
So Marcus in Freiburg, for you the last year, your experiences.
Okay, for us it was, I think, one of the most challenging years, but also the most successful one. We had also no Kurzarbeit, so we were working 100%. Challenging it was because of switching completely to remote work and growing the company by 8 people was, and coming to this, you said before, like to this threshold number where it anyhow gets a bit more difficult and you need to install processes. Doing this at the same time with this uncertainty in place for the industry we are serving was challenging. But at the end, I think everything went quite well. As I said, we had the most successful year revenue-wise, but this is was also planned because we are in the growth phase. And I think we are on the chance side of the business, because the OEMs need to develop more cost effectively, be innovative, find new solutions at lower costs, and therefore we promise to have a tool.
Thank you, Stefan, the last in the round.
Last year was our first year, so it was the new normal for us. We worked like a few months together with a team of 5 or 6 people, and then we grew, and now it's like totally normal. That's remote only. So we sometimes meet, do some testing or quality, but it's not that big. That's not a big problem to work completely remote for us.
Yeah, just looking to the time frame, I think we have to skip the final round. It was really interesting talking to you. I would have liked to continue, but we have to do this on another occasion. So I thank you very much to Dr. Markus Schiever from Skymo, Johannes Brotführer from Eliso, Thomas Freudenmann from EDI, Markus Imsen from 52 Technology, and Stefan Dengler from ChargeIQ. So I wish you all the possible success with your companies. We are really happy to have you in our network. We see just at another time. So thank you for joining us, for your interesting presentations. And for us now, this was it for today, I think. Two very interesting sessions. So for today, our e-mobil BW stream is over. You can, if you didn't have the possibility to listen to all presentations and discussions of today, you find it on the e-mobil Baden-Württemberg stream on YouTube. You can look them afterwards. So we continue. We have one part left in our this year's program to the Hannover Fair. It's tomorrow, the session Autonomous and Connected Driving in Ontario with our partner region in Canada. It will start at 5 p.m. So from my side, this was it. It was a pleasure the last 2 days. Stay safe and see you. Thank you.